Hello, 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 folks. How we doing? I hope everybody is having a good weekend so far. We'll get started in about 2 minutes. How's my mic level? Can everybody hear me okay? I'm just double checking because when I opened up, thanks, Rascal. When I opened up Twitch Studio, yeah, look at that. Look how small the on-screen chat is. It like downsized all the on-screen elements, and I don't know why. I might just edit that real quick. Look how teeny it is. All right, let me see if I can make the chat a little bigger. I don't know why. Thanks, Chris. Okay, that should be a little bit better. Well, that's the challenge, Rascal, is that if I went back to defaults for everything, I'd have to redo. I've done so much customization on this. I would have to like redo a lot of things. Oh, do I have a higher resolution streaming option? That's awesome. I didn't change anything, so it must be a Twitch thing. Twitch. Ooh, nice. Twitch must be supporting higher resolutions now, because yeah, I have a UHD monitor, and it's never Twitch has never supported that before. It's always been it always would down res everything to 1080. Nice, that's exciting. Well, let me know if anything is wonky because of that. That's probably why all my text got smaller. So, all right, let's go ahead and get into it. Hello, how's everybody? All right. So I am going to move chat so it's to the left of my video window here. And actually, I'm going to also reverse my window order. I'm going to do this, close that, and there we go. That should be better. That way we're not blocking anything important. Actually, I think that'll be fine the way it is. Oh, captions. Thanks, Rascal. Thank you, thank you. Get that going. So how's everybody's weekend going so far? Anybody do anything fun? I've been sick, so that's less fun, but I'm feeling better now. Okay, captions are on, and you are welcome to enable captions if you want or need them. If you hover over the right side of your stream window, you should be able to click on the closed caption button to get live captioning. Oh, I'm sorry to hear that, Grat. Yeah, it's Thanksgiving was a beast for that kind of thing. So I caught it from my dad. I know that for sure. Um, yeah, my dad was sick. It's not COVID. I did like 2 COVID tests over different days and negative both times. And my dad was negative for COVID too. I honestly think it was just a regular old cold, which is something that I haven't had in a while. So, yeah. Okay. Can you guys read on screen chat? Do you need me to make on screen chat bigger? I know you can read chat in the sidebar. I'm just thinking about for those watching the video, watching the restream or the VOD later. Hey, Eclectic. Watching the World Cup and working on repotting houseplants. Hey, that's fun. I love doing that. I love when you have a nice new big like ceramic pot you can plunk a plant into. It's great. All right. Well, we have a fun thing that we're going to do today. We are going to be building Tetris. So, as you can see, it is fully functional, just like the classic game of Tetris. I'm assuming that everybody here is, familiar with Tetris and how it works. I personally love Tetris. I don't know about you all, but I think it's freaking amazing. It's one of my favorite games of all time. So I was pumped to find a tutorial that kind of walks you through how to build it. Um, and yeah, so that's what we're going to do today. We're going to follow the tutorial for a while um, until we get to sort of the animation step, and then the tutorial itself kind of falls apart. But that's okay. We'll be able to finish it. This is what you're seeing right here. This is the finished product. And so we will get there together. Actually, would y'all mind if like the whole stream was just like me playing Tetris? Because I would totally be down for that. Just the entire time. Yes! Just me excelling at Tetris. Font would be a little bigger. Okay. Yeah, let's make on-screen chat a little bigger. Okay. Font is okay, yeah. That was again, that's Twitch downsizing it. I can make it bigger. I might have to make the rectangle itself a little bigger. Put it up to I'll put it up to 150 scale. Let me know how that looks. Does that look better? Tetris stream win. Only if you sing the Tetris theme as you play. Dun, da, 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 da. It's that theme slaps, I gotta tell you. Looks better, looks good. Okay, good stuff. All right. Yeah, so that's what we're doing today. And how we're building this is we're actually going to be using the Canvas API, vanilla JavaScript. So nothing, no crazy, packages or anything like that. No extensions. We're just using plain vanilla JavaScript and the Canvas API, which you may have heard of. You may have heard of Canvas API before. We've definitely talked about it. In some of my older streams. I'm not sure if we've ever actually used it. We've definitely talked about it. We've built some animated games before, but I think when we built Snake, we didn't actually use Canvas. We actually did that in totally vanilla JavaScript. And I think with Canvas, you'll see how much easier it can be if you use the tools that you're given. Which so what Canvas is it's an API that allows for 2D animation in the browser, and it's native. It's just a built-in API, and so yeah, the browser can interpret what you give it, and and draw things. So one part of it is drawing. So you can draw shapes, you can draw whatever you want. And the other part of it is animation. And so, how it animates is kind of similar to traditional hand drawn animation, and that it literally draws frames. So what a frame is like it's like a single drawing, and you take that drawing and you display it. And then after a certain interval of time, you take that drawing down and you put up the next drawing that's very similar, but there's a slight difference. And if you do that fast enough, what you get is what appears to be a moving image. And so that's what this will allow us to do. It'll allow us to draw things and animate them using Canvas. The power of HTML5 compels you. Yeah. Raid Shadow Legends. Now we're getting sponsored by Tetris. I would love that. I would go for that because I mean Tetris is free to play, and so yeah, anything free, like yeah, anybody that has a free product that you know wants to sponsor me, I'm up for that. But just like what Leon says, it has to be there can't be a paywall, right? It has to be something that people can access for free. Um, hey, Dirty Mugs, working on the full stack tracker VOD. Which one was that? Oh man, I've done so many full stack projects. I'm not sure which one they're talking about, but I hope they enjoy it. Hey, Angular. Oh, the ticket tracker. Oh, yeah, that was super fun. In a future stream, I want to add authentication to that as well. That would be fun. I do want to, yeah, I want to add more features to the ticket tracker. I thought about doing it for this stream, but I wanted a little variety. Um, work's been really busy for me lately, so I just wanted to do something fun and animated. Um, work's been busy mostly just because I'm trying to front load as many projects and as much work as I can before Christmas, so I don't have to work right up to Christmas. You know, can just get a bunch of work done beforehand, and then kind of slack off the last week. And Silva says, is it similar to drawing with plain CSS? So what Canvas allows us to do is essentially like use coordinates to draw shapes, and we'll see this. Um, and then the special thing is that it allows us to animate those shapes. So we can, we'll see how we draw these individual shapes here are called tetronymos, which I think is great. Tetronymos, we'll draw the individual tetronymos, and then what Canvas will allow us to do is keep those sort of shapes as objects and redraw them in different positions on the page over and over again. So it allows us to draw on the canvas, display it for an interval, clear the canvas, and then redraw the same shape in a different location over and over and over again. So when it runs, we'll see the shape move at a set interval. So we can see it tick down just like that. And we can also, redraw the shape when a certain input is delivered. For example, when I hit the keys, the shape rotates or, goes down to the bottom of the screen. And all of those things can be controlled, so each time I hit the up arrow, the shape rotates. And that means it needs to be redrawn, right? So that's what Canvas is allowing us to do, is redraw it in different ways. Redraw it in different ways depending on what input we provide. Yeah. Okay, so let's go ahead and get started. And because I'm a nice person, I have I've come up with a starter repo for y'all that's going to really help kind of get us off the ground quickly here. So if you want, you can head over to my GitHub and you can check out my starter code. And I see Rascal's already dumped it into chat there. I'll dump it in there again. I'll spam it a couple times. Oops. All right, there you go. So check that out. And I would highly suggest that you clone it down. You can fork it if you would like, if you see yourself, wanting to have your own separate repo and make separate changes to it and stuff like that, or if you just want to kind of follow along today, you can just clone it down. It's up to you what you want to do. But what we'll open this up, and once you all have cloned it down, we'll open this up and we'll kind of go over what's inside, what we're starting with, and then we'll get into actually building it out. So go ahead and clone that down. I'll give you all a minute to do that. Oops. There we go. While y'all are cloning that down, does anybody have any questions about what we're doing today? How we're doing it? Where's the starter code? Anything like that? Hey, Antonio, welcome. Hope you're having a good day. I'm going to hydrate for a second here. My mouth is really dry. Antonio asks, I have an interesting question. When it comes to social media, GitHub, LinkedIn, etc., is it wrong to use your real name? That is up to you. It's all about how do you want to be found, right? Do you want people to be able to find you? Like if they know your name, do you want them to be able to find your GitHub or your LinkedIn? For example, I want people to be able to find my LinkedIn because I'm trying to network, right? So I have my real name on my LinkedIn. And then with GitHub and things like that, if you want recruiters to be able to find your GitHub, how marketable do you want to be? And that's not a decision that that's not a decision I can make for you. That's a personal decision, how marketable and searchable you want to be. I was wondering if I can use one name like a nickname and use it the same across all social media. I mean, that's basically what I do. I'm Mayan Wolf everywhere. I'm Mayan Wolf on Twitter. I'm Mayan Wolf, here on Twitch. I'm Mayan Wolf on Discord. So I do kind of have a brand. And so if people know me by that name, they can find me in all of those places, and that's deliberate. So yeah, I mean, you can brand yourself in that way if you prefer. Only I wonder when it comes to job contract when you reveal your name. Well, I mean, when you're communicating with people who want to hire you, you're gonna want to, make sure that they can find you because they're probably gonna want to do background checks, and they're gonna want to verify that you're a real person and that you're not a bot or someone trying to scam them or something like that. So when you're actually like talking with, you know, people who want to hire you, you're probably gonna want to share your real name. But the point at which you do that is up to you. If you want sort of natural interest in you, then you probably will have to use your real name in places unless you heavily, you know, keep an alias across multiple platforms, like you say, kind of synchronize your alias across multiple platforms. Um, I mean, that's basically what that's what Rascal does in most places. Is they use the alias Rascal 2 everywhere. I mean, that's what I do. I use the alias Mayan Wolf pretty much everywhere except on LinkedIn. So on LinkedIn, that's where I do have my real name. Yeah, just because I feel like LinkedIn is a very professional space, and so I want people to know me by my real name there. Hello, yes, my actual name is Mr. Nugget. Yeah, yeah. So it just depends. I mean, that's up to you, right? You don't have to share your real name at any point that you don't want to. Just remember that anytime you don't use your real name and you use an alias or something like that, you will be less findable by people who you may want to get into contact with. Yeah, and that's up to you, Antonia. You can decide what you want to do. I don't know where when you say introduce yourself, I don't know who you were introducing yourself to, but um, I mean, you just got to just use your best judgment with who you're talking to. Yeah. Okay, let's go ahead and get started. I'm going to assume that folks have the starter code cloned down. Um, if you don't, I'll share the link one more time. If you're just joining us, there you go. Go ahead and clone it down. And so let's go ahead and open it up and take a look at what is in there. Um, yeah, exactly, Beveran. And that's kind of what I've done is if you just have your real name on, if you have your real name on LinkedIn, and then on LinkedIn, if you like link to your GitHub and link to your other social media and stuff like that, then LinkedIn will be the entry point, and people can find you on all those other social platforms if you use an alias on all those other social platforms. Yeah. Okay, so let's go ahead and look and see what is inside the starter code file. So inside of the starter code file, um, and Antonio, I mean, again, that's up to you. Um, a lot of people do share their real name on LinkedIn, but that's personal choice. Like I say, I do too, but it's a personal choice. Yeah, and there's really no way to stop that. If you don't share your real name on GitHub and then you share your real name on LinkedIn, yeah, you're not going to be able to stop people from, if you share your real name anywhere, it doesn't matter where it is, people are going to be able to find it if they want to badly enough. But you can obscure yourself to some degree by only using it in specific places. Hey, Ian. How's it going, Ian? Good to see you. We are building hey Ian. We're building Tetris today. So welcome in, folks. If you want to join us, we are building Tetris using the Canvas API today, just like that. I promise I'm better at Tetris than this. Um, yeah, so if you all want to stick around and see how to build Tetris in the browser using vanilla JavaScript and the Canvas API, you are in the right place. Thank you for the follow. Yay. Yay, Linux. All right. So let's go ahead and pause and let's look at our starter code. Since we just got some new folks who are joining us here, I'm gonna spam one more time the link to the starter code on my GitHub. Feel free to clone that down or pull it down as a zip file. That's up to you. Um, However you want to do it, but that's the starter code that we're going to be looking at today. Um, so let's open up that starter code and let's see what's in there. So we can see that we really don't have too many files. We have a board.js, constants.js. We have our HTML. We have our main.js, piece.js, and styles.css. I'm going to make this just a little bit bigger. There we go. Okay. All right. So we can see the first thing here is that board.js is actually empty. So we're going to be filling that out as we go through this. Constants.js, however, has been pre-populated. You'll thank me later. So let's go ahead and take a look and see what we have here in constants.js. Oh, Ian says, you should get Techie Girl to help beta test your Tetris game. Ah, they're fantastic at Tetris. That's awesome. All right. So what do we have here in constants.js? Well, first thing up here, it says use strict mode. And so we're just going to force JavaScript into strict mode. And that's just for, well, we'll see when we get there, but we're using strict mode. And then the first thing we're defining here is some constants. And these are constants that we're going to be using throughout our code. First one is columns. Next one is rows. Next is block size, then lines per level, and then colors. And so columns and rows is pretty self-explanatory. If we think about our Tetris board here on the right, it's basically like a grid, right? We've got if you sort of mentally put lines on this, you'll have lines that go vertically and lines that go horizontally. And what those do is they help build our shapes, right? We've got horizontal and vertical lines that help build the squares that make up our shapes. And so that's what this is. It's just basically, hey, we've got 10 columns and 20 rows. And these could be adjusted. Let's say you want hard mode Tetris, and let's say you want, you want to play ultra hard Tetris. You could change these columns and rows and make your board bigger or smaller. I don't know what would make it harder, to have a larger board or a smaller board for Tetris. Probably a larger one, right? Because with Tetris, the goal is to fill the lines on the board. And then this next one here is block size. And so block size is in pixels. And so essentially what we're doing is we're declaring a default size for the individual blocks in our shapes. And this block size is kind of going to be like the default base unit for our it's going to help us essentially size our, like the actual size of our board and the shapes themselves. So block size is essentially going to be 30 pixels square. Easy mode, please. All right, and then lines per level. So eventually we're going to have levels. And so in Tetris, levels are essentially as you clear enough lines. So when we say lines, again, we mean like whenever you fill a row on the board with like full of shapes, it goes away, right? The row goes away, all the shapes move down. And after you clear a certain number of lines, then you move up a level. And moving up a level means that everything goes faster. So as you move up levels, things will go faster and faster and faster and faster until finally it's too fast to keep up and you lose. So that's what that is. And again, all these can be adjusted for difficulty or things like that. Next one is for our colors. And these are just going to be determine the colors of each shape. So each shape is going to have, like depending on the shape type, it's going to have a set color. So the long pieces are always going to be light blue. The squares are always going to be yellow. The L pieces are always going to be orange, etc., right? And you might notice here, what we're doing is we're freezing this object. So essentially we want to make sure it never gets edited. We always want these colors to stay the same. We never want anything to be added or taken away from this object. And so That's why we're freezing it here. All right. So here things get a little bit more interesting. Hey, piece of shoot, welcome. Thank you for the follow, Tactics 47. Good to see you. All right, here's where things get a little bit more interesting. We have our shapes. And again, we have an array of shapes. Excuse me. So these are these essentially matrices are arrays that contain arrays. And so if you were to draw these on a grid, it would essentially be like a 3 by 3 square. So just by looking at it, can you guess what do you think this shape might be? Just by looking at it. If you think about this as like a or sorry, it's a 4 by 4. I can't count. It's a 4 by 4 grid. What do you think this shape might be? The one I've highlighted. Any guesses? So we have, think about the zeros as being empty. So let's think about it that way. Zeros are empty, and then any other number, think about the grid being filled in there. Yeah. It's a 4 by 1 line. Yeah, exactly. So first row is empty, second row is filled in, third row is empty, fourth row is empty. Yeah, so it's a line. And then if you look at this one, it's essentially first row has a value in the top left, second row is filled in, third row is empty. So it's a lying down backwards L. I don't know what you call that. I don't know the names for the tetronyms. Yeah, it's an L. Exactly. You get it. And then this is the L going the other direction, right? There's a sticky uppy bit here. Second row is filled in, third row empty. Yep. And here, this is the square here. Yeah, and so you could, if you wanted to make these more readable, yeah, you could do that. You could do like make them like this. Oops. And then maybe that looks a little bit more readable. You can see that the second line, that's just a line straight across. And this one here, you can see the L shape. And then the backwards L shape right there. Boop, boop. The square. The squiggly sort of S piece. Sticky uppy bit. Yeah. You get the idea. The T shape, the T shape piece, and then the S shape going in the other direction. Yeah. So that's how those work. So that's our shape object. This is what's going to help us draw our shapes. The next thing we're doing here is we're defining some keys. And when I say keys, I mean actual keys. So we're talking keyboard keys here. So when you press a keyboard key, it can have a certain code associated with it. And those codes are going to be numeric. So if you were just to see, like, I don't know, key 27, that's not going to tell you very much. And so what we're doing here is we're essentially mapping those key codes to their literal names: escape, space, left, up, right, down, and P. So, left and right are obviously going to be moving back and forth. Up is going to be rotate. Down is going to be, move down faster. So yeah, those are going to be our key mappings. And then we have our points. So I honestly didn't know how Tetris was scored until I saw this. So this has been illuminating for me. I didn't know how Tetris actually did the scoring. So single is 100, double is 300, triple is 500, and Tetris is 800. So by that, they're talking about the number of lines that you clear at once. So single line is 100 points, double is 2 lines is 300 points, 3 lines is 500, and a Tetris, I believe a Tetris is the whole board. Not 100% sure. Soft drop is when you push the down arrow until something goes to the bottom of the screen. And then hard drop is when you hit the space bar and it just hits the bottom of the screen right away. And these are going to be multipliers for our score. So hard drop multiplies it by 2 because it's a riskier move. And then the levels, all this is doing is just setting the levels that, you go up a level as you clear enough lines. This is just setting the time interval between piece drops. So the pieces will move faster because the interval or the space between will get smaller and smaller as you go up levels. All right. And so all we're doing here is we're just setting a whole bunch of constants that are going to help us. I'll go ahead and save this as is. Setting a whole bunch of constants that are going to be, come into play in multiple points in our code as we go along. All right. Any questions on this before we go to the next one? Again, all this is pre-populated for you just because that makes it easier. Okay, well, feel free to ask questions at any point if you ever think of anything. Happy to answer if I can. All right, next up is our index.html. And again, I've also pre-populated this for you, but we're still going to go ahead and look at it and see what we have in here. So nothing super crazy. We're importing a font here. And I'm sure most of us are aware at this point, but Google has tons of free fonts that you can use in your projects. Hey, welcome, Viper. Good to see you here. I'm doing fine. I hope you are as well. We're building Tetris if you want to stick around. So we're importing a font here, and Google has a ton of free fonts available if you want to use them for your projects. And this one's actually pretty cool. It makes everything look like old 8-bit video games, so like Mario. And again, it's a free font. You can use it for free. There's no restrictions on it or anything. And you can just link to it in your HTML. Yeah, sure, Viper. Can somebody link Viper the starter code repo so they can follow along if they want? It's on my GitHub, and I've just given you some starter code so that you don't have to build everything from scratch. That's what we're going over right now. Thanks, Roscoe. All right, and we're also linking to our CSS style sheet. Now here in the body, you'll notice that there's not a lot going on in the body. And you might be like, that's weird because, I mean, obviously we're doing a lot here, right? We're doing a bunch of animation. We are, we've got all the functionality of, Tetris. It plays, it runs, all that stuff. If you guys don't stop me, I'm just going to keep playing Tetris. Y'all got to rein me in. But here in the body, let's see what we're doing. So we're creating a grid. We've got have a div here with a grid in it. And then in there, we have a very simple canvas tag. You might be like, what's that? So canvas is where the magic happens. And the canvas actually is this entire game board area is our canvas. And all we need to do to make use of the Canvas API is simply create a canvas tag and then link to it in our code. And all the animation, all the drawing, everything will simply happen inside of this canvas tag. And that's all there is to it. Everything else happens on the JavaScript side. So we're just essentially, it's kind of like with a lot of the tools we've been using, sort of like React and stuff, you just create a hook for it on the HTML side, and then everything else happens in your JavaScript. And then we just have our score, lines, level, and these will obviously update, as our score goes up, as our lines go up, as our levels go up. And then we have another canvas here. And this canvas has an ID of next. So if I just restart the game here, what do we think that next canvas tag might be linked to? So we already know that it's not the game board. We already have a canvas tag for the game board. But do you see anything else on screen that's animated? Other than the score and the lines, those aren't. Those are just straight up JavaScript updating the HTML. But do you see anything else that's like a visual element that's animated that's not the game board, not inside of the black border of the game board here? What do you think that next canvas tag might be associated with? Any guesses? It's not the score. Good guess, though. Yeah. Schrodinger is coming in hot with the first time chat. Exactly. Yep. Yeah, it's the next shape. So that is being drawn separately because it's truly is the next shape that's going to appear on the board. So we draw this shape first and then we move it over here to the other canvas and drop it down. Hey, Rask, tomorrow I'll have to choose from 3 offers. Congratulations. Wow, that's amazing. Great work. I'm sure you put a lot of effort in, and I hope that I'm sure you'll make the right choice. But I'm sure that any choice is a good choice. Um, Schrodinger says, "I'm really behind on classes and just jumping on to listen." Well, you decided to jump in at the right point there, Schrodinger's. Good job. Yeah, and congratulations, Rask. Yeah, that's awesome to hear. I hope they're all. I hope it's I hope it's a difficult choice because all the offers are so good. But I'm sure you'll make the right one. All right. So this essentially is all of the animated parts of our page here. And then the very last thing we have is just a button. And on click, so when the button is clicked, it calls the play function that's going to be in our JavaScript. And play is going to do a lot of things. We'll see that once we get into it. But it's going to call play function, which starts everything else in motion. And the very last thing we have here is just we're linking to all of our um, JavaScript files. Okay, so again, what's kind of cool is that our HTML here is very simple, and all the heavy lifting happens on the code side, as it or on the JavaScript side, as it should. Viper says, "I have a question. I just built a voice assistant using Python. Oh, cool. I have about 17 features in voice recognition. Do you think it would be a good project to make an app to connect the software features to the app?" I think that would be pretty cool, personally. So I guess the question is, what would you want to accomplish with the app? What would be the purpose of the app? Would the purpose be just to allow people to interface with your voice assistant? Would it be accomplishing a certain goal or a task? Allowing people to accomplish a task with your voice assistant? So when you're going into building the app, which I mean, that building apps is generally fun, but what do you want the app to actually do, right? Yeah, like what advantage would that interface of um, having the app connect to your software? What would that accomplish that your software can't do on its own? I think that's the question. All right, so that's our HTML. Again, if you have any questions on this, feel free to ask, but we'll go ahead and go on to the next one here. So next is our main.js, and this one is empty. We're going to be fleshing this out as we go. And then followed by also the same with piece.js. So in main.js is where we're going to have most of the functions that are going to be like sort of driving the game itself. So that play function, drawing the board, triggering the next animation, that kind of thing. And then in piece is where we're going to basically lay out the um, essentially the properties of our pieces. So what are their coordinates? What color are they? What type of piece are they? We're going to have a class and we're going to have a constructor that's going to build those pieces and assign all those properties. So every time a new piece gets generated, every time an existing piece hits the bottom of the board and a new piece is generated, we're going to call this constructor to just, and a few functions and a few methods inside this class to build out a new piece with all new properties. All right, and then finally we have our CSS, and nothing too crazy here. We're just using we have a grid. So again, we have our grid layout, and just setting some basic properties for our, uh, score and stuff like that, and then our play button as well. So nothing crazy there. All righty. Any questions on the starter code before we actually go into adding to it? Make this a little smaller. Oh, I see what you mean. So you say, so I'm thinking about having an interface because at the moment my software is executing the features with the use of voice. Okay, so you're saying you want to, it only works with voice right now, and you want to add some kind of other interface like like typing or something like that. You have a text based version as well. I mean, yeah, that would be useful for people who um, maybe don't um, maybe don't have an accent that your assistant could recognize. Um, I don't know how trained your voice assistant is on various accents or things like that. And so yeah, having a text interface could be useful. Sure, it doesn't have to be complicated. Is you just basically would need a text box to type in commands, or you could even have buttons for common commands, right? If your voice assistant has certain common features that a lot of people are going to want to use, you could have a click button that would allow someone to just click instead of typing. They could click and it would execute whatever. Goop says, "Hey, is this going to be recorded?" Yes, yes, it is. All my VODs are recorded and they're available on Twitch for 60 days. But then prior to them expiring, I do move them to my YouTube channel. So you can do exclamation point YouTube in chat as a command, and you'll get a link to my YouTube channel. That's where all my older videos are. Anything that's not on Twitch anymore, you'll be able to find it on YouTube. Yeah, there you go. Hey, Ryan, welcome. Okay, so I'm not hearing any more questions on the starter code, but you're welcome to ask at any point. For those of you who just joined us, I'm going to spam the starter code one more time, give you another chance to go clone it down if you want to. All right, let's go ahead and get started. So we are working off of a, oops, that's not it. We are going to be working off of a tutorial to a certain extent today. But at some point we're going to kind of have to abandon it because it kind of falls apart. So it's a decent enough tutorial to a point. And then I think it has some good explanations for things and that kind of thing. And then at a certain point we'll jump ship and I'll guide you through the rest of the code. All right, let me see if I can get this arranged on screen so that everybody can see and it's not behind my head and things. I think, and I'll link to the tutorial as well if you want to have it open on your own screen too. Let's see if I can make this a little bit, move that over a titch. There we go. Hopefully that's visible. We'll figure it out. We might have to play around with the size and things, but we'll get it. Move that over. There. That should be good. Eric, actually, no. We're actually not doing any CSS today. The CSS is done. We're building Tetris today. So Tetris is going to be, we're going to be building Tetris in mostly in JavaScript using the Canvas API. So Canvas API is a built-in API in browser, but you can basically use JavaScript to do animations and drawing. So that's what we're building. I don't know who Sasha is, but cool. All right. So again, finished game looks like that. And just a quick intro to Tetris. If you're not familiar, Tetris was created in 1984. If you didn't know, it's a very old game. It's been around for 40 years, and it's timeless. Best game ever. And the game requires players to rotate and move falling Tetris pieces. You clear lines by completing horizontal rows of blocks without empty cells. But if you aren't able to eliminate the rows before they reach the top of the screen, game over. And you can also rotate the pieces in order to fit the row. The individual pieces are called tetronymos. And they're a collection of 4 blocks. So each shape is made up of 4 blocks. They're just arranged differently. And Yeah. Okay. So we've got our project structure. We've already built that out. I provided that for you as part of the starter code. We have our basic structure. Um, so let's go ahead and get into actually putting some code in our file. Um, so we've already populated everything in constants. So the playing board consists of 10 columns and 20 rows. We're using these values often to loop through the board so we can add them to constants.js. So I've already done that for you. We already have columns and rows and block size. And we also already have our index.html finished. So you don't need to do anything here. Now we're actually going to start adding some things to our main.js file. So we can get the canvas element and its 2D context in main.js and use the constants to set the size. So let's do that. Let's look at what we're doing here. So const, whoop, sorry, main.js. Okay, there we go. Const canvas, and here is where we're going to be linking our canvas to our board. Document, get elements by ID. So on our HTML, we have a canvas tag with an ID of board. So here is where we're linking our JavaScript to our canvas. And then the second thing we're doing here is we're setting up our context. And I'll say what that is in just a minute. Canvas, nope, I can't spell canvas. That's going to be a problem. Canvas.get context is going to be 2D. Okay, we catch up with chat here a little bit. Love this game as a kid. Didn't know the pieces had a name? Yeah, they do. It's Tetronymos. Viper. Yeah, I mean that sounds like a reasonable thing. Yeah, if you want to make your app to sort of auto activate the your uh, your software, that's fine. Yeah. Piece of Shoot says, I've watched a bit of the last Tetris World Cup. These guys are next level. Oh, absolutely. They all have their hands super weird on the controllers because it's like faster. I don't know. Yeah, it's wild to see. I've watched a little bit of that. It's nuts. Viper says, I don't want my software to have a GUI. Its main purpose is to automate tasks. Yeah, I don't have a lot of experience in programming like stuff like that without GUIs, without any kind of user interface. Maybe somebody else in chat has some experience with that. I don't. I mean, my primary way of building stuff is via a GUI, a user interface. Um, Tetris.io. Yeah, I've played that. It's fun. I'm not that good though. Yeah, and Rascal's giving some advice there. They might be able to help you out, Viper. Okay. I think I'm caught up now. All right, so with Canvas, we are linking the animations and the drawing we're going to do to the specific Canvas tag in our HTML, right? But the context is basically telling Canvas what we're trying to, what type of drawing or animation we're doing. And so in this case, we are doing 2D animation specifically. So everything is happening in 2 dimensions, nothing 3D or anything crazy like that. We're just saying, all right, the context of our animation is 2D. So that's going to access that library with all the 2D animation, all the 2D animation, functions and methods and things that are built into the Canvas API related to 2D animation. All right. And now we'll see that we will access this CTX to get to some methods that are built in to the 2D library with Canvas. All right, so the next thing we're going to do is we're going to set the width and height of our canvas. So width is going to be calls times block size. And so what we're doing here is we're using some of the constants that we set up earlier, right? We set up some constants. And this is going to be so we don't have to keep defining our sizes of things. We define them once in the constants, and then we never have to touch them again. Or if we do want to change them, we only have to change them in one place, right? Um, and similar to width, we can set our height as rows times block size. And then, whoops, our scale is going to be essentially how big we want everything to be on the screen. And we're doing that, setting the scale to the block size constant again. So everything is in relation to block size. And so if we were to change block size, everything would scale up or down in a uniform way. Is there 3D context also available? Yes, there is. Yeah, there is. And we've used it before. I would say it's not for the faint of heart. Most people start with the 2D version. But we did build a spinning cube. That was pretty cool. So yeah, you can get into it if you want. And if you're interested in 3D animation, that can be something you dabble in. But I do think the 2D version is more accessible because you don't have to think in 3 dimensions. But hey, some people are much more visual than I am, and so that might be a worthy challenge for you. All right, so we've set our scale for our canvas. And by using scale, we can give the size of blocks as 1 instead of having to calculate everywhere, which simplifies our code. All right, and we've already linked to our style sheet. This is just setting the font, that press start Google font, which I love. It's amazing. And we've also already set our CSS, so we can skip this part. We've already set that. So let's go ahead and save this. And now if we go over to the, if you go ahead and run this, just run it in, your preferred live server local host of choice, you'll see that our game board is all ready to go. It's the appropriate size on the screen. It looks like it's ready to receive some blocks. Hey, Real Coder. We are making Tetris today. And I do have a starter repo for you if you would like it. Oops. I don't have it in my clipboard anymore. Maybe Rascal can link to it, I'm sure. They're faster at it than I am anyway. Thank you, Rascal. So yeah, if you want to use that for starters, you can pull it down. And that's the tutorial we're following for a little while. So yeah, it looks good. It looks ready to go. Also, too, if you aren't a regular viewer, I would highly recommend that you install the live server extension in VS Code. I think most of us here have it already, but if you don't, I would highly recommend it. It's just an extension for VS Code. It's free, and it allows you to click on it and immediately start a local host of whatever code you're running. Just immediately start running it in your browser. And it's really helpful. It auto updates as soon as you make changes, so you can tell really quickly when you screw up. All right. So we have our sort of our gameplay area set up. Hey, Hanalak, welcome. Today we're building Tetris. All right, so the board in Tetris consists of cells, kind of like we already talked about, right? It's a grid of squares. And these cells are either occupied or not. So either there's something in them or they're empty. We're going to use numbers to represent an empty cell with 0. And the colors and populated cells are going to have a color value of 1 through 7. And so if you remember in our constants file, we declared 1, 2, 3, 4, 5, 6. Oh, sorry, 1, 2, 3, 4, 5, 6, 7 colors, along with a color of none, which is 0. So 0, 1, 2, 3, 4, 5, 6, 7. And so those 7 colors are going to, 7 values are going to correspond to the 7 colors, along with 0 for none. So that's what we're doing here. All right. Next, we're going to set up the rows and columns of the game board. And we can use an array of numbers to represent a row. Now the board is going to be an array of rows. And so that's what we call a matrix. So when you have an array, it's a single row. And then when you have an array of rows, that's what's called a matrix. If you've taken, I think algebra. If you've taken algebra, you should at least have some familiarity with matrices, and they do come in handy sometimes when coding. So knowing what they are is a really useful thing. If you can say, "Oh yeah, I know what a matrix is," and then describe it, I think that'll be good. Again, it's just an array of arrays, which then, if you were to draw them out, it would be like drawing a grid. So that's going to be how we're going to draw our board. And the board, we're going to draw the board as a class. So inside of board.js, so we're going to flip over to board.js. We're going to create a new class called board, and that's going to help us draw our grid. Linear algebra? Okay. Yeah, I couldn't remember. I mean, I know of them, and I was a stats major, so I took a lot of math. Didn't stick. I don't remember what I learned about matrices. Why do the shapes have different values? I'm not sure which file you're looking in right now, Hanalak, but yeah, the shapes have different values. Yeah, because they're different shapes. So in Tetris, there's different shapes, and the different numerical values inside of those shapes represent that they're all going to be different colors as well. So I hope that helps. Feel free to ask another question if I didn't answer. All right, so we're going to create a new class here. If you're familiar with JavaScript, you should be a little bit familiar with classes. We can put a bunch of methods inside of these classes. So our first one is just going to be called reset. And we're essentially just going to say, hey, when this is called, get an empty board. And then immediately below that, we're going to define the method getEmptyBoard. And define what that does. So return an array from, and I'll tell you what this is doing in just a minute. I can't talk and type, so you'll have to forgive me. And all right. So what this is doing is essentially just saying, hey, generate an array and give the array a length of rows. So again, it's just that rows constantly we already defined. And essentially we're creating our matrix, right? We're using the rows and columns, and we're creating a matrix of that has additional matrices in it. And we'll see what this looks like in just a minute. So we're going to have an array of rows, and it's essentially going to generate multiple copies of that in a larger array that are going to stack to become a matrix. And we'll see a visual representation of this in a minute. Okay. And that's just going to generate an empty, and it's going to fill that array with, it's going to fill that matrix with all zeros, because remember, zeros mean no color. It's empty values. That's what, when we start a new game, that's what we want that to look like. All right. So now let's make it so we can actually call this call this reset function, which is then going to call empty board. So let's go back over to, we built this out in board.js. And so now we're going to go back over to main.js and just say let board equals new board. And if you remember with classes, this is the syntax for, essentially initializing that class. Our play function is, remember, our play function is called when we click the start game button. So in our HTML, when we click that start game button, it calls this play function. So what do we want that to do? Well, board dot reset, give us an empty board. And also what I want to do is console log so you can see the grid that's being generated. And so instead of console logging it, just straight up console log, we're going to use console table. I don't know if you guys have ever used console table before, but it's actually nice. It gives you a it gives you a table in the console. So if you have a matrix, you can have it look very nice and pretty in the console as a table with rows and columns. All right, that. So now let's see if we can actually call this. So I'm going to do inspect here. All right, let's see. There we go. All right, so when I click play, we can see that what I get in the console is a literal grid. It's my matrix. It is it has 9 columns and 19 rows. And, or sorry, it has 10 columns. Yeah, 10 columns because it starts at 0. 10 columns and 20 rows, just like we wanted. And if we look back at our constants, we'll see that, yep, 10 columns and 20 rows. And so this is what's going to be running behind the scenes to fill in our board and draw the shapes and everything as we go. So this is what's going to be powering our entire game here, is this board, this grid of values that are just going to, basically, they're going to start out as 0 and then they're going to change to whatever they need to be to draw the shape. Yeah, so on board.js, this is all we did. I'll catch up with chat here for a second. Algebra, learn about matrices and algebra. Okay. So Hanalog, this is going to be animated. Well, we're not just going to be drawing numbers on the board. What we're doing is we're setting up the numerical values that are going to allow us to animate these pieces. It's going to tell our code what shape we're drawing and what color it needs to be. So it's going to look just like Tetris. But what we're doing is we're controlling those values by numbers. We're saying, all right, you know, if we draw, if we draw an L shape with, let's say, like ones, we know, okay, well, those are all going to be, that's going to be an L, and all these values are going to be filled in with blue. And so that's going to draw a blue L shape on the board eventually. When I wanted to become a data scientist, I took linear algebra, didn't do well, and didn't want any more of it. Yeah, that's kind of how I felt. That was not a fun time. No worries, WJS. Yeah, I hope this is helpful to just look at that. And I'm gonna, so we're about due for a break here. I'm gonna push this stuff, up to GitHub, and then I'll share so we'll still have the starter repo, which will be mostly empty, and then I'll push to a new repo that is going to be like our in progress repo. So hopefully that'll help as well. Good. All right. Awesome. Okay. So this is what's going to be powering all of our animations and our drawing. But just as a nice visual representation, that's what it's going to look like. Okay, I'll close the console here. Move that back over a little bit. And make this smaller again so we can see it. Okay, so yes, we called the function and we saw that it drew the grid that we're going to be using. And the X and Y coordinates represent the cells of the board. Now that we have the board, we're going to take a look at what powers it. Okay, so tetronymos. As I mentioned earlier, the individual shapes in Tetris are called tetronymos. And it's a shape consisting of 4 blocks that all move together, right? They never shift. They all stay together in relation to each other, and they move together down the board. However, they can be rotated on an axis. They're often called tetronymos, and they come in 7 different patterns and colors. Their names are I, J, L, O, S, T, and Z, and you don't really need to know that. That's just what they resemble. And as we talked about before, you can represent the shape using a matrix, just like this. So if you look at the non-zero values, they essentially draw that J shape lying down. And the J, L, and T always spawn with their flat side first, so they always spawn lying down. All right. So when we talk about the individual tetronymo pieces, the pieces are always going to need to know where they are on the board. They're going to need to know what color they are. Oops, I bumped my elbow on my mug there. Sorry, move that over. They're going to need to know what color they are. They're going to need to know what shape they're supposed to be. And they're going to have certain properties. And so the best way to do that is to just build a piece class. So we can store, so essentially, so we can construct multiple pieces over and over and over again. We can build a class with a constructor, build those pieces over and over and over again, and reassign them different properties every time we generate a new piece. And that's a great use for constructors, because if you recall, if you're a part of 100 devs, you should recall that constructors, the analogy was always building a car, right? And you want to build the same general type of car every single time, but you might want to change certain properties, the values of certain properties as you go. So you might want to change the color, or the trim level, or I don't know whether the seats are leather or not. But it's always going to have seats. It's always going to have paint. So it's always going to have these properties. They might just have different values as you go. So that's what we're going to do here. So let's go ahead and hop over to piece.js. And we're going to build a class with a constructor in it. Class piece. And this constructor is going to allow us to generate pieces kind of on the fly. And so again, we're passing in CTX here just to basically say, all right, we're using all these pieces are always going to be 2D, and we're just going to pass that in as a property. So we can just say this dot CTX. That's our first property. It's just going to be CTX, so don't have to worry about that. Next, we're gonna want to assign a color. So we're going to hard code this for now, but eventually we want to make it so that we can randomly generate these pieces from a list. So we're going to set up a function later on that's going to be able to pick from our predefined list of pieces in our constants file. Remember, we already defined all the pieces in constants. And so we're going to have a random piece selector that's going to do that for us later on. But for now, just to see if it works, we're going to automatically set or hard code the color and the shape. So the first one we're going to do here is we're going to build our matrix of, I'm just going to copy and paste this because I will get it wrong. We're going to do the L, the blue L. Same one that we looked at above there. So the blue L. And then we're also going to give it a starting position. And again, this is going to be defined with a function later on, but for now we're just going to hard code it. Oh, sorry, it's the J, not the L. Sorry. I do know the alphabet, but yeah, sometimes I don't. All right, so we're going to give it X, Y coordinates for starters. And when this generates on our grid, you'll see how that works. So we're setting it at a position 3 and 0. So, oops, not Q. All right, so position 3 is going to be 3 units in from the left, and then 0 is going to be at the top. And once we've set the position, now we can actually draw it on the board. So again, in piece.js, inside of our piece class here, we're going to add a method, and that method is going to be called draw. And now we actually start to get to use some of the built-in features of the Canvas API. So the Canvas API, again, allows us to draw and animate shapes in the browser. And so that's what we're going to do. We're just going to say, all right, this, using those built-in methods, we can say, all right, fill style. And we don't have to define that because it's built in to Canvas. So essentially we're saying, all right, go up here and see, all right, what is the color? The color is blue. So whatever we draw, we're going to fill it in with blue. And we're going to loop through all of the cells in the shape. And for each value that is not 0, so all these 2's here, we're going to fill those in with color. So we're just coloring by numbers here, literally. We're just coloring by numbers is all. Fill style this color for each. And essentially we would just have a sort of a nested loop here. Oops. Gosh, I cannot spell today. I have been sick, but that's no excuse for my atrocious spelling. Value X. Haven't been doing enough coding, isn't it? All right. This shape for each. Oh, I'm missing a parenthesis there. Sorry. Then I'm going to be missing one at the end too, but I'll catch it at the end there. All right. So inside of here, if the value at any point is greater than 0, then we simply fill in the rectangle. CTX fill rect. And again, that's built in. We don't have to define it. This dot X and this dot Y plus Y 1 1. Okay, so we're filling that in at each point that has a non-zero value. We're filling that in with that blue color. And I'm missing a parenthesis here, and I'm just gonna find where it is. I think it goes right there, and that should be good. Okay, so the board is going to keep track of the Tetronimo, so we can create and paint it when we press the play button. So now we just need to add a call to this draw function. Thank you for the follow, Silvex. We just add a call to the draw function, and now when we run it, we should see our blue J. I got it right this time. We should see our blue J get drawn right on the screen. So let's go back to our play function in main.js, and we have board reset. We can get rid of our console log there. Let piece and piece dot draw. All right. And the last thing we're doing here is forcing the board to keep track of the piece position. Okay, let's see if I did that right and see if I made any mistakes. All right, now let's see what happens when I click play. Hey, there we go. It drew it. It drew it. Because remember what we did is we set the starting position of our piece to be 1, 2, 3 units in. At the top of the screen, it started drawing from there. And we said, hey, for any non-zero value in this 3x3 grid, so you can kind of imagine the grid right here. We got value, 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 value. For any non-zero value, color it blue and fill in the entire rectangle. And so that's what it did. Yeah. So we have a piece on the board. Go us. All right. Good start. Any questions? Yeah, we have our blue jay Tetronimo. All right, I think it's time for a break. We're overdue. I do like to take a break at the top of each hour. So let's go ahead and do that. When we get back, we're going to actually make it so we can move this piece around. And then we're also going to define the boundaries. Oh, thank you for the free sub, Fat Cat. I really appreciate it. Yeah, I can show you piece.js again there. Thank you, Fat Cat. I appreciate it so much. um, All right, and so then when we come back from the break, we're going to make it so we can actually move this piece around the board, and then also make it so we define it. So we define the boundaries of the board, because what you'll find is that you can make a piece move around the board, but it doesn't inherently understand that a board has edges, and so yeah, we'll make some things fly off the canvas until we figure out how to contain them. Hey, yo, welcome. We're just about to take a break for 5 minutes, but today we're building Tetris. So I do hope you come back after the break and learn how to animate things or make things move around um, using the Canvas API. Yeah. All right. So I'm going to put 5 minutes on the clock here, and also I'm going to leave this code window up so that you can see it during the break. So we'll make this a bit bigger. Reset that so that folks who are catching up can still see this. What does the Canvas API provide us with? Yeah, so what Canvas allows you to do is to draw. If you think about, a canvas is what you draw on, right? It turns your browser into a canvas, so you can draw, you can animate. So that's what we're gonna be doing with Tetris. Is Tetris is a game that moves, right? Pieces flow down the board at certain intervals without direct input from the user, and it allows you to draw complex shapes and then make those shapes move. You'll see that sometimes with like logos and graphics on websites. They'll be using Canvas to animate directly in the browser. It's not like a GIF that they uploaded. It'll be a direct browser animation. And so it's a pretty cool API that's just built in to your browser. So nothing we had to install or anything like that. Just JavaScript talking to the browser and telling it to make stuff happen. Yeah, it's pretty neat. Okay, so 5 minutes on the clock. See you back in five, and we're gonna make some stuff fly around the screen. All right. See you shortly. All right, folks, we got about a minute left in the break, so go ahead and get yourself a glass of water, stretch out your wrists, roll your shoulders a few times, and then come on back when you're ready. Thank you for the follow, That Kid X. All right, yeah, I can go ahead and put this up, push this up to GitHub as well. One sec. All right, I'll go ahead and stop the timer. You still got about 20 seconds. It's gonna take me a sec to just set up this repo as well. So no rush. Tetris. We'll do Tetris demo code. We'll call it that. Create the repo. All right, there's the link. Why is 2 in the shape grid and not 1? Yeah, great question. I haven't pushed it. One second. I haven't pushed to this demo code repo yet, but I'm going to push to it here in just a second, and then you'll be able to see the code that we've done so far. But yeah, Silvix has a really good question, and they say why is 2 in the shape grid and not 1? So 2 is actually identifying what color we're making the shape. And so we actually have an array of colors in our constant.js file, and it's looking in that array and saying, okay, what's at index 2 in the array, and what's at index 2 in the array happens to be blue. And so that's how we can control the color of our objects, of our shapes. So if we were to change that color, we could make it red or green or yellow or whatever else we want in that array just by pointing to a different index. Yeah, good question though. I hope that makes sense. Okay, so let me go ahead and push this up in 1 second. I need to make this full screen for a sec because I've had issues with that in the past. Push. Git add, git commit, first, after, first, break, and git push. Okay, that should do it. If you go to that demo code repo, now you should see everything that we've done so far. Hopefully that is helpful. Rearrange my windows here. We'll close the terminal for now, and then I'll push again when we're, maybe at the next break or whenever we come to a good point. Okay. All right, so as a reminder, before the break, we essentially made it so we can now generate and draw a shape on the screen. So WJS, if you're having issues, I would highly suggest looking at the repo I just linked in chat there, and just comparing your code and seeing if maybe you're missing something somewhere or anything like that. So we can draw a shape now. So now let's see if we can get that shape to move. So we're going to do that via keyboard inputs. So with Tetris, you can use the left and right arrow keys to move a shape left and right. You move the down arrow key to move it down. You move the up arrow key to rotate it. So we're going to kind of break those up a little bit. We're not going to do all of them at once, but we are going to set up. We're going to start with the left, right, and down movement, since that's just standard movement options. And so we're going to set up our move. Essentially, we're going to set up a move object that's going to set the X and Y position as the object moves around, right? It's going to have X and Y coordinates on the grid, and those coordinates are going to determine where the shape is drawn. Okay, So now the move function, this tutorial is not always good about defining exactly where it should go. So I need to make sure that or the move object, I need to make sure I put it in the right place. So I'm gonna look at my notes here. Okay, so it needs to be in piece.js, which was where we already are. And so just below our draw method here, we're gonna add a move method, and move is just gonna take in a value of p, and we're going to set an x value. And essentially what we're doing here is we're giving this method a position, and we're assigning it to the piece. So any position we give it, we want it to be assigned to the piece. So this dot x, this dot y is p dot y. We're saying, hey piece, go here. And the piece is like, okay, I'm gonna be drawn here now. So that's all we're doing there. All right, and we've done that. And the next thing is just about assigning key values to their names. So when I say key, I literally mean like keyboard keys. So like if I hit the left arrow, I know it's the left arrow because I hit it. But from a code perspective, it's actually going to have like a numeric value. It's going to have a value of 37. However, that's not really intuitive for us. And so in our constants, in our constant.js, we've already defined those keys to have their actual names. So left, right, up, down, all those things. So we've already done this part. Left, right, and down are already defined. So we don't have to do that. And again, we're using object.freeze to make sure that we can't edit these objects, to make sure that they stay fixed and they don't accidentally get changed. All right, and now we just need to match the key press. So when you press a key, you want an action to happen. And so that's what we're going to do. All right, and so I'm going to kind of skip this part because it's a little bit confusing, but essentially what we're doing is we are sending in information about the current Tetronimo and return a copy together with the change in coordinates. So essentially we send in the current piece and where it is, and then what we want to get back is the same piece in a slightly different position. So essentially moving it around. What we're doing here is we're going to just set up const moves. And so when we hit the left key, we're essentially going to move it one to the left. So x minus 1. On the grid, we want to move it one position to the left. And when we press the right key, we want it to move one to the right. And when we press down, we want it to move down 1. Now our y-axis here goes from 0 to 20. So down on the grid. All right, and so our const moves, that's going to be inside of our main.js. So inside of main.js, thank you for the follow, Fuel Snabble. Yeah, I tell my friends all the time just to hit key number 27 and fix all their problems. Yeah. Makes perfect sense. Yeah, no. So inside of main.js, we are going to set up our moves. Now I'm going to copy and paste this just because I don't trust myself to type this properly, but let's look at it again. So we have const moves, and we're setting up an object which has several different key value pairs here. So anytime the left key is pressed, we want it to move the x value by 1, so move it to the left by 1. Anytime right is pressed, we want it to move to the right by 1 on the grid. And anytime the down key is pressed, we want it to move down by 1 on the grid. So just changing the coordinates of where the shape is located. All right, and so and again, what we're doing here is we're keeping the rest of the properties of the shape the same, not changing those at all. We're just changing the x value of the piece. Okay. I'm just looking to make sure I didn't miss anything here. Okay. So, and now we're going to go ahead and define the event listener that's going to actually attach the key presses. So when you press the down key, your code needs to be listening for that, right? Just like with any event listener, we want to be listening for a key press. And then once the key is pressed, then do the thing, right? So once the key is pressed, make something happen. And the best way to do that is by assigning an event listener. Okay. And this is going to be in our main JS, so we can put it below our moves here. All right, I'm going to make this so it's not overlapping. There we go. Add event listener. And what it's going to be listening for is a key press. So that, and when I start typing this, you can see that that's something built in. So we can say, oh yeah, it already knows what key down is. And so if it hears a key down, it knows what that is already. That's a built-in thing that we can pass in. All right, and so when the key is pressed, something will happen, an event, and the first thing we're going to do is just prevent any default key action. So we don't want, something else to happen when we press a key. We want to tell the code exactly what to do when a key is pressed. It's not going to like these key codes. I think they're deprecated, but that's okay. They still work. So the first thing we're going to do is prevent default, which is something that we may have seen before, which essentially just prevents any default action on key press. That's the first thing we'll do. And next thing we're doing is go ahead and set P. And we're looking at moves to see, all right, if the left, right, or down key was pressed, what is the new state of the piece after that key is pressed? So we're essentially saying, all right, event.keycode. So get the key code. Was it a left key? All right. And then run it into this function. And then assign it back to the piece. Now the next thing you'll see here is it's checking for something if board.valid p. We're going to type that out and then we're going to comment it out because this is a mistake in the tutorial. We haven't defined valid. We have no function, we have no method inside of board that says valid or checks anything about validity. So that's not going to work. You'll get an error if you try to run it. We'll comment that out and just the surrounding if statement. We'll just comment that out. Leave the move. We're just not going to have an if statement around it. So leave board.piece.move. Just comment out the if statement for now. We'll bring it back later. What do we do? Event prevent default. That just stops any sort of default event from happening when we do a key press. So when you press the down arrow, I don't know what the default might be, but we just don't want like the page to scroll down when you press the down arrow, right? Or sometimes a page might try to scroll or move left or right. Like you don't want to shift the whole page when you press the key. You want to tell it what you want to happen, which is make the piece move, not make the page move. So we're just suppressing any of that. All right. And since we're moving the piece, right, board.piece.move, before we draw anything new, we want to clear the canvas. So each time we redraw the piece, we need the canvas to clear. So just like with animation. So if you think about animation, what they do is they, put a frame up on the screen for just a moment, take that down, put the next frame up, take that down, put the next frame up. And so that's all we're doing here is we're taking the old frame down before we draw a new frame. Otherwise, they would just all overlap on each other. 0, 0. And essentially, we're just clearing the entire canvas, canvas.width, and CTX, canvas height. And then finally, after we've cleared the canvas, we can actually draw board piece draw. We can actually draw our shape again. All right. Let's see. Am I missing a parenthesis there? I think I might be. No, I'm not. Yeah, I just have my closing parenthesis here in the wrong place. Sorry. There. Okay, that should be good. All right. So I'm going to save this, and I want to double check something here. I want to make sure that I have the in piece, I want to make sure that I have move. I do. Good. And I have draw as well. Good. And also the last thing I want to make sure is that I have I've also defined my X and Y coordinates inside of my constructor. So now every time the piece is drawn, it will move it according to the original X and Y coordinates, right? So 3 plus 1 will be 4, which will shift it 1 to the right. X plus 1 will be 1, shift it 1 down the grid. So I think we're good there. All right, let's see if we can move our piece. All right, so our piece is generated. Ha-ha! Look what we have here. It lives. It lives and moves. So I'll go back to main.js there if you're still catching up. It is alive. Yeah, and if you notice, if I hit the up arrow, like I'm hitting the up arrow right now, if I hit the up arrow, nothing happens because we didn't set any action for up yet. We haven't like defined, we haven't defined rotate or anything like that. All we've done is defined movement patterns for left, right, and down. Now, if you also notice, what I just did there is that I can very easily make this bad boy go off the screen. So I hope that's showing up. I hope y'all are able to see that. Make sure I did move my windows around so it's, yeah, okay. Yeah, you can see it moving good. It doesn't have, it doesn't have boundaries. That's correct. Yeah. So we need to define boundaries, which we're going to do. We need to set some boundaries on our piece here. Okay. We need to give it some boundaries. So Champo, I'll do a push up to GitHub so you can see what you might be missing there. WJS, so it does work. Essentially, we haven't really animated anything yet, right? What we're doing is we're just essentially every time we touch a key, we're redrawing the piece at new coordinates. So it's essentially like we're almost like doing the animation by hand, right? It's like we're frantically sketching out a new sketch and we're holding it up in front of the camera. And that's what we're doing. We haven't really done any animation yet. We're just redrawing the piece over and over and over again at new coordinates. You mean the up button shouldn't work? Yeah. Yep, that's correct. Yeah, because in Tetris, there's no going back. You're not going up. So we are going to set a rotate. We're gonna make it rotate eventually, but we're not quite at that point yet. However, our piece does move. We just need to make sure it doesn't keep going off the screen. Okay. My eyeballs are telling me this is quite animated. Yeah. It is, and that's the secret, right? That's all that when you see a Disney movie that was hand drawn back in the day, that's all it was. It was just 2D. It was just a bunch of images flashed at you really fast, right? A bunch of still images. So yeah. All right, I'll do a push real quick. I shouldn't have started a new terminal. Whoopsie. All right. Added piece movement. I'll say coordinate movement. Coordinate changes. There we go. Okay. There we go. So now our piece can move. Now we just need to add some boundaries to our board that are going to stop it from moving too far. Okay. So we're listening. We set up our event listeners to listen for keyboard events, button presses. And each time the corresponding button is pressed, it's brought in and the appropriate function is executed. So changing the coordinates that are stored inside of our piece, the piece constructor is run, and that piece object has certain properties, one of which is x and y coordinates. And so the x and y coordinates are updated, and the piece is redrawn in this new location. Glorified flip books. Yeah, that's all it really is. All right, so now the next thing is collision detection. So when it hits a wall, we want it to stop. We have a few different collisions we need to consider. When it hits the floor, when it moves left or right into a wall, when it hits a block on the board, and when it rotates, or basically when any part of it hits a surface. So we've already defined the new position for the shape, right? We set the new x and y coordinates, and then we redraw the shape. So now we just simply need to add a validity check if the position is valid before we move to it. No worries, WJS. Thanks for stopping in. So to check for collisions, we loop through all the spaces on the grid and essentially make sure that they're valid, right? That make sure that they're not outside the grid. Make sure that the piece is going to fit in there. Okay, so we're going to have inside of our board.js, we're going to make a new method inside of our class that's going to be called valid. Excuse me. And again, we're going to be passing in the position. And we're going to be similar to before. We're going to be doing a double loop because it's a grid. So we need to loop through the row, and then we need to loop through every column. So get to the end of the row, go to the next row, loop through that, go to the next row, loop through that. Excuse me, I'm going to sneeze. 1 second. Maybe. Thank you. Oh boy, thought that wasn't going to happen there for a second. Yeah. Oh, thank you. Yeah, classic animations were sometimes animated on twos, or aka one drawing for 2 frames, cutting it down to 12 drawings a second instead of the 24. Yeah, and you can sometimes even see that in certain animations. They look a little bit choppier, I guess. And that's that, the smoothness of the animation depends on how many frames per second there are. Yeah. Thank you, everybody. All right, so again, double loops. We start by looping through rows, and then we have to also loop through the columns. Turn. All right. Yes. Okay, good. So essentially we set the X and Y values. And what we're doing here is we're checking to make sure that the new place the piece is going to be going. So the current, we set the current position plus the new X value. So the new X position is going to be px plus dx, and y is going to be essentially the same. We're just checking whether the new position that we're planning to move to is going to be appropriate. Don't want it to hit anything. All right, and then we return. Now you'll see here that in the code in the tutorial, it says something about, thanks, Ryan. It says something about this dot is empty. Yeah, that function is never defined anywhere in the code. So I just kind of skipped it. It's fine. Oh, thank you for the resub. Thank you. I appreciate it, Ryan. 4-month streak. Thank you. Wow. Thank you so much. Much appreciated. So this first call here to this dot is empty. Yeah, that's never defined. So just ignore it. That's one of many mistakes in this tutorial. We can skip it. It's fine. It's still we'll still get the point across. The next thing we're going to do is reference this dot inside walls, which we actually haven't defined this yet, but we're about to in a second. And this dot above floor. All right, so we're just going to focus on those two. And that's what we're going to do to check and make sure that the X and Y values are valid for us to be able to move to. Like extra screws when putting together furniture. If it still stands, you never needed it in the first place. Yeah, exactly. And actually, funnily enough, in this tutorial, inside walls and above floor are never actually defined either. But don't worry, I've got your back. I'm about to show you what they're supposed to be. Got them in my notes. Once I find them, give me just a moment. All right, so make sure that you stay inside of your board class. But we're just going to go down a couple here, make sure that you're still inside of that closing bracket, and we're going to have a new method here called inside walls. And Berkeley, that's essentially, well, they say if you know the limit xy coordinates, wouldn't you just want to make sure it was within those values? Well, the way we've built this, you could potentially change the size of the game board. So we have some constants that define the number of rows and columns in our game board, and those could potentially change. So we don't necessarily want to hard code them. We're just going to write a quick little method here that called inside walls. That's just going to check and make sure that it's inside of those coordinates. It's really small. It's just, hey, if x is greater than 0, greater than or equal to 0, sorry, greater than or equal to 0, and the x position is less than our calls constant. So inside of our constant.js, we have a value that sets the number of columns. That sets the number of columns inside of our game board, so it could potentially be wider if we wanted it to. Right now it's set to 10, and so this is just going to check and make sure that the x is valid in there. So inside walls, and then above floor, again, a very small method. Above floor, we're passing in the y value. And with that, we just want to return y less than or equal to rows. Because the reason we don't have to check and make sure that it's going to be like above the board or anything like that is because when we generate our shape, we have no way of moving up, right? We can only move down on the board. We don't have a, when we hit the up arrow, our piece is not going to go up. It's only going to go down. So we only need to check and make sure that it's above the bottom of the board. All right, so just making sure it's inside the walls and above the floor before we move there. And so now that we have this valid method defined, let's go ahead and go back to our main.js. And inside the event listener, you can remove the comments around if board.valid. So essentially what we're doing here is every time a key is pressed, we set up the new coordinates. We check to see if that move is valid. And only if it is, do we move the piece. If not, then we don't do anything. Nothing happens. All right, so let's see. Essentially, we're just saying if it's valid, then move it. All right, now let's see what happens. Don't forget to save. We've modified 2 files here, board.js and main.js, so don't forget to save them both. All right. Aha! So look what happens. I'm trying to move past the edge of the grid here, but I can't because that's determined as not a valid move. And so it doesn't redraw the piece. And if I go all the way to the bottom, I can't go outside of the board anymore. So now my piece stays within the boundaries that we've defined. Awesome. So now we actually have a valid play area where our pieces can go. And Death Knight says, oh, okay, talking about drawing graphics on the screen. Oh, that's cool. Creates a double buffer. On an initial loop, it would render the image to the buffer, and the next loop it would display, so you don't get any tearing. Oh, neat. Hey, Madeline, how's it going? Good to see you. We're making Tetris. Come join us. So I'm just about to do another push to the repo if you want to follow along. Added boundaries. There we go. So yeah, now we have a valid play space for our pieces. They start at the top and they can't exit the grid. And thank you for linking to the. So Rascal, if you could update your link to the new Tetris demo, like the in progress code, I think that would be helpful for folks. Just so they can keep up with the code that we are currently in progress on. So I did have a starter repo for this, but if you want to keep up with what we've done so far, oh no, you're fine. Don't worry about it, Rascal. I'll link to it here. So we have a new repo here for the in progress code. Yep. So you can follow along as we go with what we've done so far. So you don't have to start all over. All right. And clearly, we're demonstrating here that we can no longer go outside the grid. Go us. All right, no more ghosting. Good stuff. Okay, and then another classic Tetris move is what's called the hard drop. And so that's when, you can move the piece around using the arrow keys, but if you want to be, super fast and a Tetris god, you can hit the space bar and the piece will go from its current position all the way to the bottom of the screen. So that's called a hard drop. It goes bam, all the way from its current position immediately to the bottom of the screen. And so we want to add that as a move that's attached to the space bar. So we already have the space bar in our constants file. That's already there. We've assigned it's got value 32, so we can immediately start referencing it. And inside of our moves object right here, we want to add a new move called key.space. Key.space, whoops. Key.space. And we're going to, instead of moving it just by one, we want to essentially move it, we want to essentially move it all the way down to the bottom. Oh, gonna ban someone here. One sec. There we go. It happens. Quick on the ban hammer. All right. How many screens am I looking at? I have two monitors. One's much larger than the other, so the one that you're seeing is my large monitor. And then the other one I have my notes on is just an old small monitor. Yeah, I'm going to have two monitors that are the same size because I think that'll make things easier. But right now I have a large Ultra HD monitor and then a small crappy monitor. So that's where chat is and that's where my notes are. So if I don't see somebody's chat, dual monitor gang, yeah, dual mismatched monitors, which is the best. All right. So let's see, for space key, let me make sure this is right. For space key, dual monitor. Yeah, I don't honestly, I mean, no shade to anybody that doesn't have two monitors, but I don't think I could function without, I don't think I could function without two monitors, to be real. Okay, so what we're doing here is we're setting up something that is going to look very similar to the down key. So we're essentially just saying, all right, move it by one. And you might be like, but isn't the space bar supposed to drop it all the way to the bottom of the screen? And yes, that's technically correct. But we're going to make that happen in our event listener. So essentially what we want to say is if somebody presses the space bar, we're going to have a while loop that's going to keep moving it down by one, like as fast as it can, until it no longer has a valid move anymore to move it. So it's going to be doing the same thing as if you were pressing the down key, but it's going to be a while loop that's just going to keep calling that and changing the coordinates until it can't move down anymore. All right, I thought it was fun. Monitor got to and can't go back. Scared all the same feeling if I get a third now. Yeah, I have three monitors for work. So my work setup actually has three, and I had four monitors for my work setup for a while. And yeah, no, it's hard to downgrade once you've experienced the majesty of multiple monitors. You know, two isn't enough these days. Yeah, exactly. 127 monitor and one technically a 40-inch TV with HDMI. Nice. Hey Jaguar, it's impressive that you can watch each monitor with a single eye. So I'm not sure if that's a dig about my vision or not, but I actually can't see things, separately out of both my eyes. I do have strabismus, which means that my eyes point in slightly different directions. But I just mostly glance back and forth so that I can see chat. Because yeah, they're kind of far apart actually. One's over here at like kind of an angle, and then the other one is right in front of me. So I do have to glance back and forth. So if I don't see somebody's chat right away, that just means that it's like, I gotta like glance back and forth. So I do. I think I keep up with it pretty well though. All right, so we've done our. Let's see, we've done our space key, and so now we just need to set up our while loop so that when you press the space bar, that it actually just keeps moving the piece down until it can't move it down anymore. Okay. So in the event listener, we want to, let me make sure I get this right. So if the move is valid, I've gotten this one wrong before. Swap the wrong pages all the time. All right, so let's see. I'm just double checking here. Word valid. Okay, so yeah, essentially what we want to just say, all right, replace. So we can replace this if statement here. And we want to, instead of if now, we want to say while, I think. Else if board valid. Yeah, okay, so here's what we're going to do. We're going to do this. While board.valid is P, and then we want to move it, and sorry, I'm kind of want to make sure. Okay, no, we don't want to replace the if statement. We want to say if key code. Okay, that's right. If event key code equals key dot space. Yeah, because this is one of the ones that it will end up slightly different when we're done with this code. But for now, we're just going to make it simple. So I'm just going to grab this and put it here. Yeah, I think that'll do it. Then I have an extra parenthesis, get rid of that. I think that'll work. Okay. Board piece move. Okay, let's try that. All right, so now theoretically, if we hit the space bar, we should be able to do a hard drop. All right, so, oh, but I accidentally got rid of my regular moves. So let's do, wow, board not valid. Let's add an else statement to this. This is a little bit different than what's in the tutorial, but I think this is what we're going to want to do. So I'm just going to grab this from my notes and then while board valid, event key space, while board valid, do that, do that, do that. Okay. And I'll take that out. Else if board valid, and then move. There. Okay. There we go. Okay. So now I can move, and let's see what happens when I hit the space bar. Hey, look at that. Oh, cool, Tetris, yeah. An ultra widescreen monitor would be nice. Yeah, I don't actually, mine's not actually ultra widescreen, I would say. Whoop. Mine's not actually ultra widescreen, I would say, but it is widescreen, and it's ultra HD, so that means I can just fit more on the screen. If they can have their own display, mint. Yeah. It might be a little challenging with Linux. All right, there we go. So now when I hit the space bar, we can do a hard drop all the way to the bottom of the screen. Okay, cool beans. Let's see what's next. And again, the way this is working is it's just doing a while loop. So once you hit the space bar, it enters this while loop, and it just keeps executing that key down and changing the Y coordinates until it can't anymore. Trapped in the box, poor little fella. Yeah. All right. What's next? Rotation. Yeah. So one of the main principles of Tetris is that you can rotate the pieces, right? And there's a little mathematical explanation for how rotation works, and I don't know. I mean, if you're familiar with mathematical matrices, this might be relevant to you. I should be familiar because it was what I did in college, but I don't remember any of it. So if this helps you, that's awesome. I just kind of copied the algorithm, so you can do what you want. But what we're going to do is essentially we're just going to write a function that does this rotation for us. So it's going to take in the grid, whatever that grid is. Some of them are 3x3, some of them are 4x4. But essentially it's going to be a square, and we're going to change the values inside of that matrix such that it looks as though it's been rotated one turn to the right? So it start like this, and we just want to turn it like this. Yeah. Free the Tetronymous. And so they give us the, luckily they do give us the algorithm for this. And so we're gonna create a function that does this rotation. And what we're gonna do here is essentially we're taking the current grid, doing the rotation on it, and then returning the new version of it. We set up a clone, and then we return the clone. Okay, so and where we're going to put this is because they don't I think it's in board.js. Okay, yeah, we're going to put a new function in board.js. Yeah, go get some food. Absolutely. Oh, thank you, Dav. I appreciate the sub. Wow, thank you so much. I'm feeling the love today. Thanks, guys. All right. So in board.js, below our above floor method, still inside of our class, we're going to create a new method called rotate. Rotate. There we go. And we're passing in the piece, and we do all that transposing and stuff. And I'm going to copy this shell right here and let clone. I guess they're passing in P here. And then the algorithm. Again, I'm not too concerned about how this works, only that it does work. And then return. Okay, and that's going to accomplish the rotation for us. And then the last thing that we need to do is just attach this method to an actual key press, right? So in Tetris, in general, when you press the up key on the keyboard, you would expect that to trigger rotation of the piece. So let's see if we can do that. And it says to add this into board.js, and that's incorrect. We want to actually add that into main.js, because that's where all of our other moves are. So it says board.js, that's wrong. It needs to be in main.js. And it's going to be key.up. What happens when the key.up is pressed? Well, all we need to do is rotate the board. Is anyone what is that show? Gosh dang. Mitchell and Webb. Anybody know the show Mitchell and Webb? It's a British show, BBC show. Whenever I hear rotate the board, I always think of one of their skits. It's this zany game show called Number Wang. And yeah, and it's like it makes zero sense, and it's all like crazy nonsense numbers. And yeah, one of the things one of their catchphrases is rotate the board, and the board just spins and it doesn't mean anything. I don't know, it's just funny. Yep, exactly. Well, and so you might say, oh, wait, are we rotating the board or are we rotating the piece? Well, the only reason we're referencing board here is that we have it as a method inside of board.js. So it's inside of board.js, but we're actually rotating the piece. So I can see how that's confusing. It's just we have rotate as a method inside of board.js. So that's why that is the way that is. Good question, though. All right, so we have our key up now. Now let's see. I may have missed something here, but we'll give it a try. Let's see. Did someone request this project, or is it a personal interest of yours? I love Tetris. I just think Tetris is really fun. Hey, look at that. It spins. Rotate the board. No. Rotate the piece. Yeah. So now we can do all the classic Tetris moves. Spin it around. There we go. And you notice that it does still allow us to rotate it at the bottom of the board once it reaches the bottom. But we're going to fix that a little bit later by freezing the pieces once they reach the bottom. So as soon as they can't move down anymore, we're going to lock them in place. We're going to have a freeze function that's just going to freeze them. So that doesn't really matter right now. What matters is that we can actually rotate it on its axis. And yeah, looking more like Tetris all the time. We're getting there. Okay, so I'm going to go ahead and do another push. And I think we'll take a break. And let me see where we're at here. We're doing good. We're I think we're about halfway through the tutorial. So, and we're about to deviate from the tutorial a little bit. Like I mentioned earlier, there's a lot of issues with this. I mean, it's not necessarily, it's the tutorial gives a great foundation for what we're trying to do here. But eventually we are going to have to deviate from it because it basically stops making sense. Things are wrong, things are missing, things are not mentioned. So eventually we're going to deviate from it and kind of branch out on our own. But what we're going to do next after the break is actually make it so that we can randomize the pieces. Um, I love it too. I've been addicted to it a few times over the years. Yeah, no, it's just so like inherently fun. It's just such a cool game. I love it so much. Um, so the next thing what we're going to do when we get back from the break is figure out how we can randomize our pieces um, to essentially pick one of these shapes that we've previously defined, pick one of these shapes at random, right? So we've got the line, the L, the J, all those things. We're going to pick one at random and drop it onto the board. And so, but since we have an array here, what we can do is essentially just randomize the selection of one of the values in the array, right? And then also, pair it with the appropriate color. So that's what we'll do when we come back from break. I need to hydrate. Mm. Happy Sunday indeed. Thanks, Madeline. All right. Here we go. Let's go ahead and start the timer. I'm going to do another push of code. And that way, anybody who's just joining us or who might have a mistake somewhere, you can access the repo. Added rotation. There you go. All right, I'll see you back here in 4 minutes and 30 seconds. All right, folks, we got about a minute left in the break. So make sure that you know, stretch out your wrists, stretch out your shoulders, get a glass of water, pet your dog, pet your kid, I guess. Do whatever you got to do, and then come on back. I currently have only water in my tea mug here because my teapot is or my tea kettle is still broken and it can't boil water fast enough during the break to actually like I can't boil water fast enough in the microwave over the break in order to make tea. So I'm stuck with water. It's okay. I'll drink stupid water if I have to. All right, stop the timer. Don't worry, I'm getting a nice new tea kettle for Christmas, so I'll be able to boil water again. Oh, what is up with my hair? Heating water in the microwave. I know. I wouldn't be doing it if my friggin' kettle wasn't broken. Yeah, I gotta heat water that way for coffee, all that stuff. I know. I know. No, I love my electric kettle, and it's straight up just stopped working. I even took it apart and tried to fix it. And apparently, it's a common problem with this particular model of kettle is that the heating element goes bad. So, yeah. All right. So let's see if we can. Right. So right now, whenever I, reload the page and start a new game, I always get the blue J piece, right? And that's because we've literally hard coded that. So in our piece.js, we have hard coded the shape and we've hard coded the color um, to, you know, give us the same thing every time. So now we're just going to randomize that. So Scotty says, "Where's your secondary and tertiary kettles?" So I'll tell you what. So I'm getting a kind of a low cost kettle for Christmas for my parents, but I'm also planning on buying like a nice high end one. But I can have now I'll have two kettles, and so what one of them goes bad, I'll always have a backup, and I'll never have this problem again. Lover John says, randomize the shapes. Yeah, and that's what we're gonna do. We are gonna randomize those shapes. Yep. And so we've actually already done the first part here. The first part is just defining the constants. Um, and we've already done that. So if we look inside of our constants, we've already defined these shapes appropriately. So we don't have to do that. That's in the starter code. And we've also already listed out all the colors. So we have those things already. Don't need to worry about it. And so now we're going to set up our actual randomization ability. Is it a weird UK thing to always have one spare kettle in the house? Get one with temperature control. Yeah, so the one I'm getting for Christmas won't have temp control, but the nice one I'm planning to buy myself has all the all the gadgets, bells and whistles. Yeah, Madeline, that's the one I'm going to buy. It's going to have the temperature on it, and you can, has a button for tea and a button for coffee and all the appropriate temperatures. Yeah, so that's what I'm looking forward to. But I didn't want to burden my parents with trying to find that type of a gadget for me. So they're getting me a standard one as my backup, and then my good one is going to have all the fanciness. Yeah, the one I was looking at wasn't EXO or OXO. It was I don't remember. It's whatever the New York Times recommended it as like the best kettle. So whatever I'm just like, all right, fine. New York Times, tell me what to do, and so it was that one. Okay, so in order to get an actual random piece, we need to pick a random number. And so we all kind of know how to do that, right? We can do math.floor, math.random, and then essentially just multiply it by the number of shapes that we have. So essentially, we're just saying, all right, pass in the number of shapes and then return a random number that's somewhere in that range, right? Um, and so with this method, we can get a random tetronymo type when we spawn and then set the color and shape from it. So after we get that random tetronymo type, we're essentially going to get that random type and get the correct shape and the correct color, because the way that the shapes and the colors are set up is that they align with each other. So um, the line piece, the long skinny line, that one aligns with the light blue, that cyan color. So they're at the same position in their respective arrays, right? So if I say, if my randomized function returns a 1, I simply just pass that in to both the shapes and the colors array, and what I get back is a line piece and the color cyan. And so that makes it really easy to generate the correct shape and the correct color at the same time. So that's what we're going to do. However, this tutorial, again, is missing context. And so we need to do a little bit more setup, because if we go back to piece.js, you'll notice that all this stuff is hard coded in here, right? We're hard coding the color, we're hard coding the shape, and we're hard coding the starter coordinates. So we need to let's set up our randomized heteronomo type function, or method, sorry. And I'm not going to spell that right, so I'm just going to grab that. Okay, randomized heteronomo type method, and we're going to return math.floor, math.random, and then times what we passed in, number of types. So now we can access that method. And we also can set our type ID, which is actually going to need to be added to our piece constructor as an additional property. We want to store the type ID as a property of piece. Let me just check something there. Okay, yeah. So what we're going to do is we're going to kind of modify this constructor portion a little bit. And I'm only doing this because I can see the future, and I know that we're going to be adding some additional things. So let's go ahead and above the constructor, we're just going to add some, we're just going to set up some characteristics of a piece. We're just going to set up the X. This is where we're going to start to deviate from the tutorial a little bit. We're going to set up X just as values inside of every single piece. We're going to set up Y. We're going to set up color. And for now, we're just declaring these. We're not assigning any value to them yet, but we will. Shape, context, and the type ID, which we just talked about. Again, that's just what we're passing into both the color and shape array to make sure that we get the same shape matched with the same color every single time. Can't wait for future kettles that feature Wi-Fi and 5G. Oh no. Yeah, not necessary. Yeah, and a subscription payment for temperature controls. Exactly. I would add really messed up pieces just to troll players and remove them with microtransactions. Oh, that is devious. Mavi, you should be an app developer, like a work for Candy Crush or something. All right, so we're setting up these various properties first. And then in our constructor, instead of hard coding all these values, what we're going to do instead is we're still going to set the context here, but instead of hard coding all these values, we're just going to call another method called spawn. And what this method is going to do is it's just going to set all the values outside of the constructor. And it's going to generate them sort of using the, it's going to call randomized heteronomo. It's going to set the shape. It's going to set the color. And then it's going to be assigned via the constructor. You're all lucky I don't like coding games because I would wreak havoc. Oh, devious. All right, so let's set up a new method here called spawn. And what this is going to do is it's just going to essentially assign everything that's listed here. Spawn in the piece before it's drawn, assign all the properties, and then all we have to do is draw it. All right, so this dot type ID is going to be equal to um, randomized tetronymal type, and instead of colors.length, it should be colors.length minus 1. And why is that? So yes, the tutorial is wrong here. Should not be colors.length. It should be colors.length minus 1. Why? All right, and then yeah, 0 index. Yeah. Or actually, maybe it doesn't need to be. No, I think it still works. All right. We can try it both ways and see what happens. All right, that's not going to matter. Okay, so this dot shape is just going to be shapes type ID. Whoops, sorry. We pass that in to our shapes array and get back the value, the appropriate randomly generated value. And then this dot color is going to be colors type ID. Okay. And I think that's all we need. Oh, and then we also want to set the initial coordinates to be 0 for both, for X and Y. You might be like, well, wait, don't we want the X to generate at 3 like it has been? Technically, yes, but there is a slight weirdness about Tetris where some shapes don't start at the same coordinates as others because some shapes are long and skinny, others are short and fat. And so we are going to have a separate method that's going to determine that. But this is going to set all these default properties, spawn the shape, and then it will be drawn according to the properties that we've set here. So after that, it essentially just goes, so it spawns first, and then it gets drawn and filled depending on the color that we just set here. So the random color that we just set gets filled in, and just like we did before. Where is the long one? So the long one is right here. That's the line. So if you look at the in the constants file in shapes, the long one's right there. It's the one. So if you think about it as a matrix, this second line here, all of them are filled in, and what those ones mean is that they're all filled in with cyan. So they're all filled in with cyan, and in this this J shape right here, those are always going to be filled in with blue. And the 3s here for the L shape, they're always going to be filled in with orange, and so on and so forth. So the long one is right here. Okay. Let's see. And we already have move. We have randomized tetronymo type. And so the last thing that we want to add here as well in the rotation. So in the which rotation are you talking about? Are you looking at the GIF here on the screen? I think that's just the way they captured the GIF. And it could be the way that they coded this too, because they said colors.length. And they didn't say, yeah, no, it's all good. And they didn't say -1. So I don't know that they're capturing, I don't think they're capturing the line piece because it's the first, it's like early in the list, but I could be wrong. So I think that's an error in the code that we have hopefully corrected, but we'll see. If we never get a line piece when we run it, we can do some troubleshooting. All right. So the last thing I want to do here is also just set starting position. Because when we, in the spawn function up here, we set our coordinates to X and Y, both being 0. So if we did it this way, that would mean that everything's going to spawn in the top left corner. And for Tetris, that's not what we want, right? Everything should spawn relatively in the middle of the screen. But some shapes are slightly different shapes, right? So occasionally we might want them to spawn in a slightly different location so they still look centered. So set starting position is just going to do that for us. And if the type ID is 4, whatever that one is, it needs to spawn in the 4th X position on the grid. It needs to spawn in X position 4. Otherwise, it's going to spawn in the usual place of X position 3. Okay, and I think I want to make sure that we're calling that somewhere. Oh, actually, we may not call that until we actually start doing our animation, so that's fine. Things might spawn in the top left corner for now, but that's not going to be a hardship for the moment. All right. Let's see if this works. Oop. Let's see, did I get an error? I did. Okay. Randomized heteronomo type is not defined. Yes, it is. It is, it is. I must be referencing it wrong. Ah. This dot randomized heteronomo type. Let's try that. Nope. Oh, I did that multiple times. Okay, this dot type ID is not defined at several locations. Okay, that's fine. All right, so we defined it here. But since we've put it into the spawn function, we're going to need to clean up a couple of other places in our code. And that's okay. So we're going to need to do a little bit of cleanup in other places, but it's going to be worth it because we want to have full functionality for the rest of the features of our code. So let's go ahead and do that. I'm going to go ahead and push this so far, and we'll do some cleanup. Git add. Oops. Changed piece properties and added methods. All right. Okay, so that's pushed up to the demo code repo. And now I think we've done everything we need to do in piece. So that's pretty much done. X, Y, color, shape, type, ID. Hey, After Work Tech, I like your name. Do you practice coding after work like I do? And I code at work too, so just different types. All right, so we've got our spawn. Excuse me just a minute, I'm just checking my notes. We've got our draw. We've got our move. And the last thing I want to do here is inside of my move method, I also need to make sure that we are passing in shape, because inside, whatever we change the position of our shape, we're not only passing in the coordinates, we're also passing in the value of the shape itself. And so we want to make sure that we're getting that out. So whatever we call move, we want to make sure that we're getting that out as well. So last thing we need there is just the definition of the shape itself, coordinates and its definition, and so that it knows what shape it's supposed to be moving. All right, I think that's good. Randomized heteronomal type. And and also in randomized heteronomal type, I think we're going to want number of types plus 1. Yeah. Okay, I'll push this again because I made some changes. And again, that's just the array, the array length. We want to make sure we're capturing everything in the array. Git commit, small tweak. That's very descriptive, right? Okay, there we go. So now our piece.js should be fully complete. Now we just need to make sure that the rest of our code knows how to reference it properly. So they know how to take in all the information about the piece and move it around and draw it and all that sort of thing. So what we're going to do next, now that we're done with piece.js, is let's go ahead and work on our board. So we don't have a ton of stuff inside of our board for now. And since we're mostly going to move away from the tutorial at this point, so I'm going to kind of make the code window here a little bit bigger. Make sure y'all can still see it. Good. We're going to move away from that for now. We'll still go back to the browser to test and make sure that, once we are able to get things working, make sure that we can run our game. But for now, I'm gonna kind of take over because the tutorial kind of breaks down past this point. Okay, so we just finished up with piece.js. Let's move to our board and get that set up. Freestyle, yeah. And we're going to do something kind of similar like we did with piece.js. And Afterwork says, when I have time, now I'm mostly just working after work for work. Oh, that's too bad. It's too bad when your job starts to take over your free time as well. That's unfortunate. So in our board class, we're going to do kind of similar to what we did in our piece. Is we are going to just set up some initial, properties here. Just declare them for now. CTX next. Grid, piece, next, request ID. And then we're going to, use a constructor to build them and have a bunch of methods that our constructor is going to reference. So essentially, we're just kind of cleaning this up and making it a little bit more sensible. So we declare everything first. Then we have a constructor, which is going to set all the values, but that constructor is calling multiple methods below it in order to set those values. And some of these might not make sense immediately, but they will. So again, context is our context. Context next is what's going to help us preview the next piece. So, when we were looking at the board earlier, so if we look at the finished product again, remember we have the ability to actually display the next piece on the game board prior to loading it into the, so if I do, we can see the next piece is listed. That's not a good example. There we go. Okay. So the next piece is going to be a T piece. And there it is. So yeah, we have the ability to display not only the current piece, but the next piece as well. So that's what we're setting up there. We have our grid, which is, the grid that our game is played on. We have the piece, which is the current piece that we're drawing. Next, again, next thing. We have the request ID, and this is related to animation. So in animation, you draw a frame and then you request that the next frame be ready for you. So you have a request for the next frame, and then that frame is displayed. Get the next frame, display it, get the next frame, display it. And so each request is going to have a request ID. And so for things like a pause feature, what you want to do is when you click pause, you want to stop the animation, right? No more animation. And so when you click pause, you essentially cancel the next request. And so that's what we're going to use this for. You want to cancel that next request, no more frames, don't get another ID, pause until we resume. And then the time is what's going to help us control our animation. So our animation is going to run at a particular interval. And as we saw earlier in our constants file, as we go up in levels, those intervals are going to get faster. So the pieces are going to fall faster. It's going to get harder. And so that's how we can control that using time. Okay. So now below where we declare everything here, we're just going to have our constructor. Pass in the context, kind of like we did for pieces. Context is always going to be the same. It's going to be, 2D. And the context for the next piece, again, which is going to be the same. The only reason we're really passing it in twice is that we have two canvases. So we have the canvas for the current piece, and then we have the canvas which is right next to it for the next piece. So CTX and CTX next. And so we just set that property. Easy peasy. Oops. And the next one is just going to be CTX next. CTX next. And then after that, we need to set all the other properties. And so we call a method that we're just about to define called init. So this is our constructor. It's going to set all these properties. Um, yeah, and it's going to help facilitate our animation. After work says goal is to have finished all projects up to the new year. Then I can start working on some things I want for myself. Actually, so after work, I'm actually doing something very similar myself right now. I was mentioned at the sort of toward the beginning of the stream is like, yeah, I have a bunch of projects that are need to be done by Christmas, but I'm actually like really busting my butt right now to get them done early so that so that I can really slow things down closer to Christmas while still accomplishing all of my responsibilities at work. So I feel you after work tech. I'm doing something really similar right now. I'm just pushing as hard as I can so that I can get everything done well prior to the Christmas holiday. So I wish you best of luck with that. I'm hoping mine goes well as well. I'm hoping mine works out as well. All right. And so what we're going to do here is essentially we are moving the initialization of our game canvas into a method called init. So earlier what we did is we set our canvas size just kind of randomly inside of our main.js. We just kind of plonked it in there. And actually that's, really not the best idea. So we're going to move it we're going to move it out of main.js and we're going to move it into our board.js because it just makes more sense to be there. So I'm going to grab these 3 lines where we set our width, height, and scale. I'm going to cut them, move those out of there, and I'm going to drop them into board.js and format them a little bit. Okay, so that's going to be our initialization. It's now part of the constructor. I can save that. And we're also going to have a new method that's going to, well, actually, no, we already have this method. So we're going to modify our reset method a little bit. So instead of just getting an empty board, we're going to do multiple things. We're going to not only get the empty board, we also want to get a new piece. So, if I click new game, I want it to get the empty board and also retrieve a brand new piece, set the starting position of that piece. Basically do, reset everything, not just the board itself. So I'm checking something here. Good. Yeah, that should be okay. And I am gonna adjust the name of get empty board. I'm gonna change this to get empty grid because that's essentially the first thing that we're gonna do. Get an empty grid. Get empty grid. And then get a new piece. So in order to do that, all we need to do, since we have a piece class with a constructor, right? We set up a piece class with a constructor inside of it. All we need to do is just call it new piece. And we just pass in the context, which we already have, new piece context. And then call the starting position function. Set starting position, which we defined. That was one of the things we just built inside of piece.js was a new function called a new method called set starting position. So we can call it here. And then get new piece, which is a method we're just about to define. All right, so now when we reset the game, we're not only getting an empty grid, we're also getting a brand new piece to really start the game over. Same here, going to try to have my half-baked projects all polished by New Year's. Yeah, there you go. It's a good goal. All right, so next thing we're going to define here is get new piece, which I don't think we already have. Just double checking that. No, we don't already have it. So get new piece is next. Get new piece. And what we're doing here is we're essentially passing in, so we're getting we have our new piece that we're actually passing onto the board, and then we're getting we're sort of teeing up the next piece that's going to display to the right of the canvas, as being on deck. So this dot next is going to be new piece, and we're going to pass in CTX next. CTX next, and inside of our little next canvas, we want to clear it and then write the new piece to it. Clear rectangle, and this is built. This is a built-in method with Canvas, so we don't need to define it. This CTX next canvas dot width. And canvas.height. All right. So that'll clear our little mini canvas off to the right where we display the next piece. And after that, all we need to do is draw it. This dot next dot draw. Okay, make sure I did that right. CTX next. Clear the canvas and then draw the next piece. It's just this one that's going to show up on the right over here. Oh, my game's still going. Whoopsie. All right. And after that, let's see, do we already have a draw? I think we have a draw method somewhere, but I don't think it's here. So we're going to need to move our draw method here in order to make sure that we can actually draw the piece. So new draw method here. We'll get rid of the other one once we find it. This dot piece dot draw and draw the board. Draw board. So previously what we did is we essentially summoned all the information that we needed, and then after that we draw the board and we draw the piece. Okay. Let's go ahead and look at our valid method here. So we previously built this one, and it checks to make sure that when we do move a piece, that that move is going to be valid. So this is almost fine. We just need to add one additional element to it. So inside of our return here, we want to do a couple of additional checks. So really all we've checked so far is to make sure that the piece is inside the walls and above the floor. However, we also want to make sure that if it's at the top, then if the initial value is 0, if it's at the top, like basically if it's just spawned in, then it's going to be a valid move no matter what, because it's always going to spawn in the right place. So if it's just spawned in, then it's perfectly fine. However, we do want to add one more check to our inside walls and above floor, so that's good. But we also, as we start adding more than one piece, so right now all we've done is we worked with a single piece and we moved it all the way down. However, what we're not checking is any sort of collision, right? We need some kind of collision detection to make sure that there's already not a piece in the position we're trying to occupy. Otherwise, they're just going to overlap. So we're going to add one more additional check here. This dot not occupied. And that's going to check both X and Y coordinates, right? Because we don't want any part of our piece to be touching any part of another piece or overlapping any part of another piece. Yeah. So that does mean that we need one more initial check. So we have inside walls, above floor, and we're just going to add not occupied as an additional check. And what that's going to do is it's going to look inside of the grid. Remember, we're drawing a grid essentially behind the scenes. We're just drawing a grid of numbers. And that grid of numbers, if it's empty, if a particular square is empty, it's going to have a value of 0 inside of it, right? So if a square is empty, it's going to have a value of 0 inside of it. And if it's occupied, it's not going to be 0. So essentially, all we need to do is just check and see that the coordinates that we're trying to hit don't have anything inside of them, that they both equal 0. So checking to see that all the possible coordinates are 0, and what that means is that the square that we're trying to move to is not occupied. Okay. And I'm going to check our rotate here. I think that's fine. I don't think we need to change that at all, thankfully. P-shape length. Yep, that's fine. Return the value. Actually, I'm going to say return P here instead to be consistent. Okay. And I'm going to need to add an additional method here. Oh, no, I don't think I need to add it. So we have this get empty grid method up here. And I am going to push this in a minute. Don't worry. We have this get empty grid method up here. The grid, a digital. Oh, yeah, it's Tron. Oh, and thank you for the follow, Frick94. I appreciate it. The grid, a digital frontier. Nice. That's a great reference, GZ Adrian. I love it. So we're just going to make a slight adjustment to our get empty grid function here. Return array from length rows. Actually, no, we don't need to adjust this. Never mind. It's fine. Forget I said anything. Okay, so we've got a get empty grid. Okay, I'm just going to do a quick scan here. I think we're going to need to add a couple more methods. It also reminds me of what's another one that reminds me of it? I think it reminds me the most of Tron. When you're thinking about a grid and stuff like that. But there's something else. I can't think of what else it reminds me of. Something else, yeah. Good reference though. Okay. Let's see. We have init. We have reset. Get new piece. I promise this is the longest part of this whole thing. So after we get through this, then all we'll need to do is just set up our functions that call all these things, and then we'll have a fully functioning game. So don't fret. All right, get new piece. We've got that. We've got draw. Generic synthwave background videos. There you go. All right. So another method that we need to add is the drop method. And so what drop is going to do is it's essentially going to control the movement of our piece once we animate it, right? So right now, of course, when I hit a key, I can make the piece move. And we set those coordinates and we do all those things depending on where you move it. However, we don't have anything that's that our animation can use to essentially drop the piece down and trigger additional actions if needed. So what happens is, as the piece falls, right, it's eventually going to hit the bottom of the screen, right? Or it might be in the correct position to fill a space in a line. And then by magic, without me doing anything, that line should disappear, right? So we need this automated drop, and we can just call that drop. And it's going to basically check and see, it's going to move the piece. It's going to check and see if the move is valid, and it's going to trigger like a line clear, or if it hits the bottom of the screen, it's going to stop the piece from moving anymore. So our drop here is essentially just going to trigger like a key down. It's going to mimic a key down because we already have that written. It moves the piece down. So we can just reference that and have our animation trigger that automatically without us touching a key. So essentially, we just say, all right, automatically move the piece down as if we were hitting the down key, but we're going to be doing it on a certain interval. So if that move is valid, we can call our this.valid. If the move is valid, or the new position is valid, this.piece.move. If it's a valid move, move the piece. Sure. This.piece.move. If it's not valid, so essentially, if there could be a few reasons why the move isn't valid, right? It could be colliding with another piece. It could have hit the bottom of the screen. Could be a variety of things. However, if the move isn't valid, in general, we want it to stop. We don't want it to move anymore. So we're going to have a method called freeze, and we're going to call that method. But if it meets the particular condition where it is also sitting in a spot on the line that means the line should be cleared, we also potentially want to clear the lines. So that's going to be another method as well. So there's a lot of things that could potentially happen, but we're going to have methods that are going to handle all of these contingencies. So however, if it gets to a point where there is no valid move, right? If the move is not valid, but the piece is in Y position 0, which is the top of the screen. So if the piece is trying to move and it can't, and it's at the top of the screen, what condition do y'all think should trigger? Piece is at the top of the screen and it can't move. What should happen? Just based on what we know about Tetris. Oops. Oh, thank you for the follow, Elias. Game over. That's right. Didn't that happen in Tron too? Where like if the two light bikes collided, then it was game over. What was the point of that light bike game in Tron? Does anyone remember? What were they trying to do? I just remember them racing around and zigzagging past each other. But what was the goal? Was it a race, or were they trying to hit each other? So if the piece is at the top of the screen, it's a game over condition, and we just want to return false here. Is anybody a Tron aficionado in the audience? Because I don't remember enough about that movie. All right, so at any point, as long as we didn't trigger game over, right? We might have, hit another piece. We might have cleared a line. So something could have happened here. But in any case, that piece's journey is over. So that piece is done. It should be stopped. And what we also need to do is once that piece is to a point where it can no longer move, we want to freeze it. And then we also want to trigger a new piece to spawn. Because this piece is done, immediately trigger the next piece and send it down the screen as well. So we can just say this.piece equals this.next. So essentially we're just calling, setting up the next piece to be generated. Set it in the appropriate starting position and get the new piece. And then that starts the process all over again. To kill the other player, so the point of the light bike races in Tron was to kill the other player by cutting off their path. Oh, vicious. Okay, that's right. I remember because they were drawing like the line. They were drawing like the line behind them, and so if you hit the line, it's like Snake. It was like high stakes Snake. You couldn't hit the line. Haven't seen Tron in ages. Yeah. Yeah, it was like the Snake game. Exactly right, Cheesy. Aha. Okay. Yeah. I did see that. I actually saw the sequel to Tron Legacy, prior to actually seeing the original Tron. So I was a little bit. I don't necessarily have any nostalgia for it. I just think it's a neat concept. All right, and so if at any point this, if at any point there is no valid move, then a new piece will be triggered. However, if the moves remain valid, we're just going to return true from this function. So outside the parentheses, we're just going to return true. Okay, so this is the drop that is going to be repeatedly called by our animation. So our animation is going to be moving the piece down the page, continually checking to make sure that where it's moving the piece is valid, and checking to see if any other conditions need to be triggered, such as freezing the piece when it can't move anymore, and clearing any lines if you have scored. If you put it into a point where a line should be cleared, you've completed a line, and that line should disappear. So that's a drop. And that should be good. And so with that in mind, and I realized I screwed up my capitals. Wait, no, that's fine. It's capital L. Good. Okay. So the next thing we do need to define is our freeze and clear lines method as well. Luckily, these are fairly simple. So clear lines is just going to essentially take the current Y value where our piece is landed and clear that line. Just cut it right out of there. So we're just going to set up a new variable here called lines. Techno-themed multiplayer snake. Yeah, I think that's pretty much what it was. Yeah. Visuals of the original were pretty nuts for their time. Yeah, and so the interesting thing, some of y'all probably know this already, but is that in the original Tron, they could computer generate like the light bikes and the grid and stuff like that. That was computer generated, which was amazing for what year it was. But they didn't have any way to put the actual like actors' faces into the computer generated output. They just were not capable of doing that. And so what they did is they or they weren't so that's they weren't like capable of like computer generating like the actors. And so they what was it, they like rotoscoped the live motion video of the actors faces and like plugged them in. So that's why the actors faces look kind of weird inside like their light bikes and stuff like that. Was because it was like rotoscoped onto the computer generated light bikes. So it was a hack, but it was a brilliant hack for the time. All right, so for each row in our grid, essentially for each box in our grid row, we're going to essentially do a check to see, oops, too many parentheses there, sorry. We're essentially going to go along the row and we're going to check and see if all of the values in that row are greater than 0. Because remember, in our grid, values are 0 if they're empty, and they are greater than 0, so any number between, I think, 1 and 7, if there is a shape occupying that space, right? And so in a completed line, such as, if I had shapes all the way across the bottom here, all of those values would be greater than 0. So if they're all greater than 0, we can just do that check. If they are, then we just want to delete the line entirely. And then what we're going to need to do, since we're deleting a line at the bottom, is add a line back at the top to replace it. So we already know how to do that just using array methods. We can slice that line out of there and then add a fresh line at the start to replace it. That's all zeros. Multiplayer online light cycle game would be a neat project. Yeah, it would, MC. I agree. That would be really fun. Like, yeah, just Tron light cycles. You could do it like top down, like top down grid style. That might be easier. You could just build it like you would like multiplayer Snake. Or I mean, I don't know. I don't know that first person light cycle, like a first person multiplayer light cycle game would even be playable because you'd have no way to tell how the grid was, you have no way to strategize because you're just like, only able to see what's in front of you. So I don't know. It's an interesting thought. All right, so if every value in the row that we're checking is greater than 0, all we need to do is get rid of it. And it could be possible that we have more than one line that we're able to clear. You might have gotten a 3 in a row, right? You might be clearing 3 lines at once. And so if you are, we need to have that ability as well. So there could be more than one line, and that's going to affect our score as well. So, if you clear 3 lines at once, you're going to get more points. But in any respect, as many lines as you do clear, we're going to just get rid of them. And add a 0 row at the top. We're going to use unshift for this. And essentially just fill in as many lines as were deleted. So we don't have to know exactly. We can just say, hey, for the number of columns, just fill the grid starting at the top. So using unshift, we'll start at the start of the array, and we fill it with as many columns as we need to complete the grid. And I'm missing a parenthesis right. Grid column fill. Make sure I get that right. And there, yeah. Okay. And so that's going to do the mechanical work of fixing the grid. Oh, hey, Faster Wyverns, welcome to the stream. Thank you for the follow, Kurteric16. So Faster Wyvern says, just a quick question from a beginner. What does this, like in line 62, do? Yeah, so let's look at that. All right, so yeah, this is, it's always hard to talk about without saying the word this. But yeah, so the keyword of this is something that you'll find referenced quite a bit in this code, especially when you're working with things like classes in JavaScript. So what this can do for us is allow us to essentially kind of reach up to the parent object. So, okay, let's think about it. So clear lines is what we call a method, and it's like a nested function inside of a class. So I can access from within clear lines, I can access anything inside of it with no problem, right? But if I want to call another method from, let's see, let's find a good, yeah, like get new piece. So if I want to call get new piece from inside drop, I use this keyword to reach up to the parent, which is the class that we're in called board, and go and grab this additional method. So this says, all right, go up one step, grab get new piece, and reference it. Because if I just tried to call get new piece, it wouldn't be able to find it. Yeah, and there's a lot that goes into this keyword, but in general, yeah, and it's kind of like this is, so Mavi said this is like signaling here. Yeah, I suppose so. But yeah, there's a lot of different uses for it. In general, what we're using it for here is being able to reference additional methods outside of the current scope. If anybody has a better explanation, feel free to share it. But that's kind of how I see it being used mostly here. For example, we're calling inside walls, which is down here. We're calling above floor, this dot above floor right here, and not occupied right here. Yeah, this is this keyword has quite a lot of baggage associated with it. But yeah, it's a good. It's when you start working with classes, it's a good keyword to play around with. Um, and yeah, Mavi Sunshine has a great way of summarizing things on Twitter, like making little guides and that sort of thing. Um, and so yeah, check out Mavi's Twitter page if you want to learn have a quick primer on the this keyword and other things. Okay, so let's see, where were we? We were, great question though. I like it. We were inside of the clear lines. Yeah, okay. So we did that. Remove our lines. And then the last thing we just need to do is set the score. So if you remove a line, that's when you start scoring points. So if you removed one or more lines, we're going to award some points. And we'll set, we haven't set a count yet, but we will. So here, essentially what we're doing is we're going to be setting the score value and the lines value based on how many lines we cleared. So that's all that's going to do. And we're also going to move the level counter if we have cleared enough lines to move to the next level. So if account.lines is greater than or equal to lines per level, then go to the next level. And so again, that's going to tick this counter up to the next level. Move up to the next level. And if we didn't make it up to the next level, we reduce the number of additional lines needed to get to the next level. And if we move up to the next level, what we're doing here is we are, let me go back to the constants here. Lines per level. Oh yeah. So when we go back to, when we, there we go. We essentially just remove the number of additional lines needed to get to the next level and increase the speed. Whoops. Stop. Okay, it's not going to let me do that. Timed out level. We want to physically increase the speed that the pieces are moving. So inside of our list of constants, we actually have speed values declared for how fast the pieces are actually going to move. So we go into that array and we say, all right, the higher level that you get, the higher we're going to go inside of this level array, and the faster the pieces are going to move. And it gets really fast by the time you get into like the higher levels. I don't know that I've ever made it past like level, I don't know, 10. Madeline or somebody like that might have made it higher, but yeah, I always time out eventually. Okay, so that's that for clear lines. I'm going to go ahead and do a push. And git commit, board methods. Okay, there we go. So the GitHub repo is current. Oh, I just realized I didn't save main.js. Darn it. Well, we're going to come back to that. So board.js is at least current. I think we have valid. We did that. The next one we're going to want to add after clear lines is the freeze method. And when a piece hits the point where it can't move anymore, we want to make sure that piece can't move anymore. So essentially we're going to just hold it in place. Let's see. For each all right. Okay, so if at any point if at any basically any position that value is greater than 0, so any individual square that we're trying to touch is greater than 0, then we set the final stopping point for the piece. And x value, x and y. Okay, and that's all we need to do there. Okay. After that, let's see what other methods we're missing. We're almost done. We have get empty grid. Oh, next thing we need to do is we're going to move our draw board function into here, into our board class. It just makes sense to be here. So just drawing the board, which I believe we referenced earlier. Each. Now that we need to keep track of multiple pieces, so we can draw an individual piece, no problem, and that piece is going to move. But once we start freezing pieces, we're going to have to actually be able to draw multiple pieces on the board simultaneously. So what this is going to do is help us draw the entire board, not just the one piece that we're working on. So for each row, what we're going to do is check every single row on the board, not just, the one that's occupied by our current piece. For every single row on the board, we're going to look inside of it. And if that value is greater than 0, remember, our whole board is drawn with zeros, and then any spot that's occupied by a piece is going to be a value that's greater than 0. So if that value is greater than 0, then just fill the square. Fill style. And fill it with the correct color, because it's currently occupied by a shape, and so we need to illustrate that. Fill the rectangle with the correct color, and these are for all the shapes that have already been placed. So they're not currently being moved. We're just filling in those spaces with color so that we know what spots on the board are occupied by other shapes. So that's going to draw the entirety of the board with our individual shapes being drawn separately. All right, then we have get empty grid. Valid. That's done. We have inside walls. Grid, inside walls, above floor, not occupied. Rotate. And the last method that we need inside of this massive board class, this is the, and I'm sure you all are bored at this point, This is the largest class in the entire thing, which is why I didn't want to do it last. Um, but the last thing we need to do is essentially just assign the appropriate number of points depending on how many lines we've cleared. So if we've cleared multiple lines, we have a point multiplier for that. Oh, and I realized I never responded to what Chris said above. Mine Wolf Tetris movie trivia stream when? Yes, I have quite a lot of movie trivia that I never have the chance to line clear points that I never have the chance to discuss. So um, I'm always up for that. I know way too much about random useless trivia with movies. I don't know about you, but I'm one of those people that's like always on IMDb. Like whenever I'm like, as soon as I finish a movie, I'm on IMDb. I'm trying to figure out. I go to the trivia page and I just want to see everything about it. So essentially, all we're doing here is we're just saying, hey, if we cleared one line, then assign the single point value. If we cleared two lines, then assign the double point value. So I'm going to copy and paste here. Points double. And so on and so forth. Point single, let's see, lines 3 is points triple. And here we're just using ternary operators. You could do this as an if. You could do this as a case statement if you wanted to. I kind of prefer case statements for stuff that's I shouldn't say case. Switch statements for stuff that's has multiple potential options like this. But that's really a personal choice. A lot of people don't like switch statements, and I don't know why. Can somebody enlighten me? A switch statement. Why switch statements are unloved. All right, so that assigns the point values, and then we just return the account up one level and the total number of points that we have achieved. Okay, whew. I think we're done with this one. Wowzers, that was a lot. I'm going to do a quick check on it, and then I'll push it, and then we'll take a break. And after that, we're going to do let's see, we've done piece, we've done, yeah. And so after that, we really just set up the few basic functions. We set up the few basic functions that we need to call in order to trigger all of these methods that we just set up. And then after that, our game should work. We just basically set up the animation, start drawing frames, call those frames on an interval. And because we've already set up all the logic that's going to make that work and do the right thing at the right time, so then we just basically need to call it. Yeah. All right. Because yeah, we're done with piece, constants. Yeah, so we're nearly done. Good stuff. All right, I'm just going to double check this real quick. We'll have a break. When we come back, we will home stretch this baby. All right, we set up all of the components of our board, set up the constructor, initialize the board, reset the board. New piece. Is it with a different color? Yeah, we'll see. Piece. Get new piece. Canvas width, canvas height. This dot next dot draw. This dot piece dot draw board. We drop the piece as it moves. Essentially, we're just triggering a key down action automatically on an interval. So every such and such milliseconds, we just do an automatic key press, move it down, move. If we're ready to clear a line, we just splice it out of the grid and unshift, add a new line to the beginning, or multiple lines if we need to. By using the fill method here on our array, if we've cleared 3 or 4 lines, it'll just fill it all up with zeros no matter what. at the beginning. Since we used unshift, it will fill it all up at the beginning. Shift. And if we cleared more than one line, we get some extra points. If we've exceeded the number of lines needed to get to the next level, we increase our account level. And we decrease the, the speed at which we increase the speed at which the pieces fall. Perfect. If we need to, we freeze the piece. We can draw the board. Draw all the shapes on the board, not just the one we're working with. Get our empty grid. Check validity. I think that's good. Check whether inside the walls, above the floor, not occupied. Rotate the piece if we need to. And get lines cleared points. Yeah, we're good. Okay. So I'm going to do another push. And then when we come back, we've already got our main.js, well started. But we do need to make some, add some additional calls to all these new methods that we just created and set up our animation. So after we do that, we will have a playable game. Okay, git commit finished board.js and git push. Okay, 5 minutes, and then I think we're going to wrap this bad boy up. Oh, and then people answered my questions about switch statements. If you don't use break, you end up not quite getting what you want. That's true. Yeah, if you forget your break keyword, you're gonna have a bad time potentially. And yes, and you can't easily one-lineify a switch statement. That is true. Mavi says switch statements are my least favorite way to do conditionals in every computer language I've ever used. Ooh, that's harsh. I see where you're coming from, though. That's fair. Okay. All right. Once again, if you want to catch up to this giant block of revisions that I just did, you can by picking up the repo, which I have just spammed in chat for you. And with that said, let's go ahead and take 5 minutes, and then we'll finish this up once we come back. We're very nearly done. And we'll add some animation. We'll finally get our animation working. All right, reset and start the break. Go ahead, get up, stretch, do what you got to do. And when we come back, we'll finish up. Okay, folks, come on back when you're ready. Get a drink of water, like I'm about to do. Pet your dog, pet your cat, pet your favorite human, with their consent, of course. And then come on back. All right, I'm going to go ahead and stop the timer. Is that a reference to something? Pet the pizza? I think I saw Chris said it the last break too. If there's a pop culture reference that I'm missing, I need to know I need to know what it is. This is very important. This is vital information that I need. All right. Let's see. So we finished up our piece.js. That's done. We have finished our board.js. So we have all the logic and the methods that we need. Excuse me, my voice is going. And we already have our constants. So really now we just need the kind of the we need to just kind of ignite the spark and trigger all the animations and trigger all this logic that we've built in. So let's go ahead and do that eventually. Well, Rascal, so Rascal says I'm referencing that same Chris comment. Don't know if they were referencing some pop culture thing, but I feel like this is how trends get started. You know, one person. All it takes is one person to reference something else that somebody said, and then it becomes a meme. So, yeah, I feel like that's legit. All right, so in our main.js, we're initially linking to our canvas. We're getting our canvas context. We are going to add a couple of additional variables here for our tiny little next piece canvas. So we have our canvas next, which is our little window that displays the next piece. And so we just hook to that. That's already in our HTML, and it's called. Oh, I didn't turn my camera. Wait, did I? No, I didn't. Sorry. Yeah. And it's tagged with an ID of next. So this is literally referencing the canvas HTML tag with an ID of next. And CTX next is again just 2D context. Mind me. I'm convinced I'm the anomaly of somebody else's fever dream. That's fair. Okay. Now let's go ahead and set up a couple of values for the score that we're keeping track of. So we're just going to have an object to store those in. Because what we're essentially going to do is grab those, set them using the methods that we've already set up, and then drop them in this object and assign them to the appropriate HTML element. So we have in our HTML we have lines for score, level, etc., etc., and we just need to drop them into the appropriate ones. So we just need to set score. We'll declare all of these as 0 for starters, score, level, and lines. All of these are 0 for starters. And then the next thing we're going to do is just set a function that's going to update them in the HTML. So we're going to pass in a key value pair of some kind. Maybe it's like score 10. So we'll pass in the key as the word score, and then the value will be 10. And so we pass those in separately because we can use that to assign it to the appropriate HTML element. So we can say let element equals get element by ID and just search for it using the key. So for example, if I pass in score of 10, I can say, all right, get element by ID score, and then it would go into the HTML and say, oh, here's a span with an ID of score. I know I'm going to be targeting this. So that's all we're doing there. And say, all right, if the element is found, which it should be, we should never have a situation where it isn't, but you never know. Weird things can happen. So we say element dot text content is just going to be set equal to the value. So what it does is it finds the right element. So let's say, score of 10, element's going to equal, all right, get element by ID score. It finds a span with that ID, and then we just set the content of that span to be 10. So easy peasy there. All right, and then next, we need to set up a essentially we need the ability to update the values here inside of our account values object. We need to update the values inside of our account values object. So we're going to say let account equals new proxy. So this proxy is something I hadn't seen before, but they're using it here. Account values, and from what I can tell, it's kind of a way to take an object. A proxy is kind of a way to take an object and change its behavior, like overwrite its default behavior. But if anybody has a better explanation, I'm happy to hear it. If anybody's used proxies before, I would be curious to hear what you've used them for. So essentially, we're just updating that account values object. Yeah, we're intercepting some default behaviors and replacing them with our own. So what we're doing here is in the set, we are updating our account values target, calling this update account function, and passing in the key value pair, and then returning true. Okay. I don't know how much opportunity you would normally have to use proxies, because it seems like you normally do want the default behavior, but in the rare occasion, I suppose, you want to change that behavior, you could use a proxy. Hey, LN Media, welcome. Rascal says, lastly, use proxies to intercept accessing Mongoose models to implement tracking for my Express visualizer, so one can see the arguments passed to a method and the values returned to it. Oh, okay. So you wanted to see, so rather than just accessing the module and not being able to see what was going back and forth, you used a proxy so that you could see those values, from what I understand you're saying there. Could you just do return by itself there? Maybe so. Yeah, we can try it. Let's get it working first, and then we can always come back and try it without the true. All right, and so we are also then just going to declare a variable called request ID, but we're not going to assign a value to it right now. And if you recall, many moons ago, I mentioned that request ID was going to be how we were going to control starting and stopping the animation. So the request ID is just essentially the ID of the request for the next animation frame. And so if we want to stop the animation, we just turn that off. So we're just declaring this variable for now, so we have it. And then we also have our moves, which we've already finished setting up. Let's see, I don't think we have a board method yet. We don't, or a board variable yet. So let's go ahead and do that. So instead of saying just let board equals new board, we're going to do a couple of different things here. So we're going to say let board equals new board, but we're also passing in the context and the CTX next. And this is essentially what's going to help us initialize both our regular game board and the next piece value. And we also want to call our add event listener and our init next. Oop, not that. Stop it. I hate it when it does that. Stop auto completing things. All right, we'll have to come back and add that because it's not going to let me until I actually define that as a function. So we're going to call add event listener, which is going to just add event listener to the button. And then we're also going to call an additional function here, which we haven't defined. So we'll just do that next. VS Code says, but I'm helping. Yeah. Thanks, VS Code. Let's just go ahead and define you so you shut up. All right, function init next. Jeepers. There you go. Now you get it. All right. So here, all we're doing is we're just initializing the canvas for our next piece. Init next. CTX next dot canvas dot width. It's just going to be 4 times the block size, which is 30. So it really just needs to be large enough to fit the pieces, because that's all we're displaying. Remember, our next canvas is the next piece that just sits next to the board and shows you what it's going to be. So it doesn't have to be very big. Just a 4x4 grid is enough to contain whatever piece we want to put in there. So that's all we need. CTX next. Oop, I spelled height wrong. That would definitely come back to bite me. Okay. And then CTX next dot scale is going to be the same scale, just 1 by 1 that we used for our block size. There we go. Okay. Height, width, and scale for our little tiny next piece canvas. LA Media says VS Code heart. Yeah, I do genuinely love VS Code. Its annoyances are very small in comparison to the value that it provides. So much agreed. I love VS Code. It's great. I can't believe I spent so long just writing code in like Notepad. I actually, to be real, I still use Notepad++ for work. That's how I write SQL for work. It's just what we use. I don't know. I mean, I could use VS Code if I wanted to, but I'm really used to just writing it in Notepad++ for work, so I just haven't switched. It keeps you sharp, right? Because you got to handwrite. There's no autocomplete. You just gotta. Well, I guess there is, but there's no like IntelliSense or anything like that. It is very manual. All right, so let's take a look. We did our moves. Let's take a look at our event listener here. We need to add a couple things to it. So we do want to add a couple of additional if statements for, we want to add a couple of additional if statements for if we want to pause the game or immediately end the game. So we can pause the game, excuse me. We can pause the game by pressing P, and we can immediately end the game or game over by pressing escape. So we want to add those as additional things that we could do that it's listening for on a key down event. Excuse me, you take a drink. I don't know why I decided to do a marathon stream like this, like right after I was sick. Like that was not the smartest choice I've ever made. But I just really wanted to build Tetris, okay? Whew. Beverin says, no SSMS or Toad. I mean, yeah, there's tons of tools out there like that we could use, but I work for a university, and so they tend to be about 10 to 20 years behind like everyone else in technology. So Zavatron says, wow, you're doing this without frame. Yeah, I mean, we're just coding it out with vanilla JavaScript and using Canvas to render the animation. So, and I mean, I know it's been a while, so this is essentially what it's going to look like when we're done. Just functional Tetris. Yeah, we're wrapping up. We're making good progress. Thank you, Zavatron. It's been a while since we've been able to hang out. It's a tomorrow mind problem. Yeah, it's not like I got work tomorrow or anything, right? Jeez. But yeah, it has been. I did skip last week because I was sick, and so yeah, don't mind doing a longer stream today. Okay, so in our event listener, first thing I'm going to do is enclose this in a function, because right now it's just sitting out there like a meatball, and so I am going to enclose this in an actual function. So function, so we can call it add event listener. Just wrap that in some nice cozy comfy brackets, so it's not just hanging out there by itself. Bad practice to do that. So add event listener, key down. If we hit the pause key, so if event.keycode equals key.p. So if we press the pause key, which we previously defined in our constants, so our code will know that if I say key.p, it'll look in that list of key types, and it'll identify which key that is. We don't have to identify it by numeric value. Then we're going to call our pause function, which is essentially all that's going to do is just stop the animation. No, come on. VS Code, please stop. Is there like a how can I stop that from happening? Anybody know? Because I really don't like it. if I'm trying to reference a function I haven't declared yet, how do I do that? I don't want to turn off all autocomplete though. I just want to turn off autocomplete like for this particular thing. Is it just okay? I guess just hitting escape first. Yeah, hitting escape first does it. So yeah, that'll do it. Oh, VS Code. Yeah, I was able to just press escape and it went away. All right, and then next, if I press the escape key, well, if I press the escape key, so event key code equals key.escape, ESC, ESC. If I press escape, I also want to call my game over function. So game over. There we go. All right, and then if neither of those conditions are met, I can just continue into the rest of my previously defined scenarios. So if it's not a pause key or an escape key, then we want to prevent any default behavior, like a page down or who knows, anything that could be triggered by pressing one of the arrow keys. We don't want the page moving around. And we set up our move, like we set up our new coordinates where the piece is going to move to. If we press the space key, we want the piece to go all the way from wherever it is down to the bottom. So essentially it just keeps repeating a key down move until it can't anymore. That's what we call a hard drop. So piece move. And we also want to activate our hard drop score multiplier. So as soon as you do a hard drop, if that hard drop results in a score, you want to do a hard drop multiplier on it. And board piece move, P moves, key down, board piece. Okay, good stuff. Else if it's a valid move, you want to move the piece. And if the event is a hard, if the event is a, if you're pressing the down key, then you can do something called a soft drop. So you can force the piece to move more quickly, even if you didn't like press the space bar. You can still, press the down key and have the piece move more quickly. So if the event.key code was just you pressing the down key, that's what's called a soft drop. And so that can still get you a few extra points. So we can say account.score plus equals soft drop. There we go. And that will give you a few extra points there. Now, At the very end of this function, we have a couple of things where we're clearing the canvas and we're drawing the piece. We won't have to do that anymore because we've sort of automated that now in additional methods. So we no longer need those two lines about, I'll put them back here real quick. We no longer need these where we're clearing the canvas and we're drawing this again. We're taking care of that elsewhere now, so we can get rid of them. We're just checking for the validity of the move. We're not actually executing the move anymore in this particular function because it really doesn't belong here. This particular function is about listening for specific key presses. Just because we listen for the key press doesn't mean we're necessarily going to move the piece. There could be other things that need to be considered, such as whether we've, hit something else, or, if we've just had a score, we're going to have some other animations that need to trigger. So this should really just be listening for the key presses. Okay. And next, we're going to add one more method to reset the game, and then we're actually going to write out our animation. We're going to write out our animation functions, which are actually going to finally do the animation to move the pieces down the board. So by animation, I'm talking about the timed intervals that cause the piece to drop automatically without us actually, triggering it with a key press. Because we've already seen that we can make the piece move by pressing keys, but what we haven't seen is how to make the piece move by itself. So that's what we'll do after we set up our reset game function. Rascal says, "Yeah, it's nothing with It's all or nothing with IntelliSense." Yeah. Hey, Apernaki, thank you for the follow. Zevatron says, "Is that like single responsibility principle?" Yeah, I mean, in general, um, with your functions, you want to make your functions sort of um, really only do one thing. So you don't want to function as much as possible. You want to make, small, readable functions that really have a single purpose. And then you can reference those functions from within, you can have a bunch of little functions and then, call those functions from within inside other functions. So you can still do all the same tasks. You just don't want them all happening, in one massive function that takes up the entire page. You just want your functions to be single use, and that makes them really modular. So if they do one thing and they're fairly generic, you can call them in multiple places, and so then you only need to modify it in one place if you want to make a change. Oh yeah, I can do a push for you, Shanpo, no problem. So in theory, you want your functions to be, as focused as possible on accomplishing one task. That's not always possible, but git commit. Okay. There you go. It's pushed. But I mean, there's nothing wrong with writing bad code. If you're getting into it, you don't have to feel like you need to write the best code in the world. As long as it works. And I mean, you can build cool stuff with terrible code. A lot of people have done. But if you want other people to read it, and if you want to be able to go back and revisit it later and understand what you did, the more, if you can use best practices and if you have the time to do so and the ability to do so, then you might as well, Yeah, functions should do one thing and do it well. Exactly. But potentially functions, if you write a function that does one thing and does it well, if you can also make that function applicable in multiple different locations, fairly generic as well, then like I said, you can, use it over and over again. Yeah. Okay, so all right, reset game is next. Make sure I get outside of my function here. Yep. Okay, so for reset game, essentially when we reset the game, that's like if I were to click the play button, that would set. I want to make sure that I reset all my scores, my line count, so how many lines I've cleared, and whatever level I was on. All that should be cleared. I want to make sure I reset the board, and I want to make sure that my time interval goes back to default, so back to 0. So we'll be using time for our animations here pretty soon. So for now, we're just going to set it. We're going to start it at 0. Time start of 0. Elapsed should also be 0. So this time object is what's going to help us time our animations. Essentially the interval between our animations. So, and that interval between the pieces moving down the screen is going to depend on what level we're on, because as you get to higher and higher levels in Tetris, the intervals between piece movements should shorten, right? The pieces should move faster and faster. So that's what we're controlling here. Okay. So reset just resets all those values. And then we're going to modify our play function slightly to not just reset the board, but just reset the entire game, because we have so much more now than the board, right? We have all the stuff we just talked about. We have our score, we have our levels, time intervals, that kind of thing. So I'm essentially just going to clear this one out. We're going to reset the game, and we're going to start our timer. So that's going to start our interval ticker for our animations. So start that clock that's going to trigger our animations. So we start our time. And if there is an old game running, so if we are currently trying to request the next frame of the previous game, right? So if I click that play button to reset the game, but we've already said, hey, grab the next frame to move the old piece down, I want to make sure I cancel that. So don't draw any frames from the old game, just cancel. And that's actually a built-in function that we can call cancel animation frame with that request ID. So whatever frame that was, toss it and stop the animation. Hinsau has, is this from scratch? No. So this is based on a really cool tutorial that I found. Unfortunately, the tutorial has many problems. So we've been kind of freestyling it here in the latter half of the stream, but the tutorial has a lot wrong with it, but I still commend people who do write tutorials, because even if it's not great, it still gives a great jumping off point for building something really cool. So, I mean, I couldn't have, I at my current skill level, I couldn't have built Tetris completely from scratch, but if you have, a good tutorial to start, or a decent tutorial to start from, you can get a lot farther than you could otherwise. So I love tutorials, just because they give you a great platform to learn new things. Like, for example, I didn't know like what proxies were, or any of those things. Oh, come on. Using some of these things in really novel ways. And I don't have much experience with Canvas either. So it's a great way to learn new things in a kind of a safe and fun way. Yeah. And with so many of these things, everybody's done it before, right? But you can always learn a new approach for your personal projects by looking at some of these things that people have done before, because they might have a completely different thought process than you. Hey, Hodence, welcome. Yeah, for the newer folks here that are just joining us, we do have a repo. And that's why I put all my GitHub code out there for you guys to use. So that Tetris demo code repo that I just put out there, that should be current as of a few minutes ago. I just did a push, so you can follow along if you want to. All right, so now our play function has been revised to first reset the game. So we reset the score, we reset the level, the timer, all those things. And we also clear the board and redraw it as a bunch of zeros. And then we restart our time for our animation frame ticker. we cancel any potential requests that might still be out there for the old game. So if it's trying to get the next frame of the old game, cancel that. And then we call this animate function, which we actually haven't written yet, what we're going to do next. And so animate finally actually does the animation. So function animate. Scroll to the bottom. Uh, just the last thing is just this reset game function, which I don't think I pushed yet, but I will in a minute. That's all that's down here. Yeah, I'll do it. I'll push it in a minute. We're just wrapping up the last couple functions that we need, and so once we're done with that, I'll do a complete push. Hanso I says, since you like SQL, do you think ORM is bad? I'm hesitant to say that any tool is bad, right? If it helps you get work done, if an ORM helps you get work done, um, then then it's not bad, right? Um, Personally, I've always just used raw SQL. Like that's all I've ever done. I've never used an ORM actually. Um, I've always just written in pure SQL, written and read pure SQL. Um, so I don't have any real experience with ORMs. Um, I think yeah, it's the right tool for the job, right? I think if you can learn to read and write basic SQL without the aid of an ORM, I think that can be a good thing, because there will be times when the ORM just can't get the job done. It can't do something for you that you might need. And so if you know how to just straight up write the query that you want in just straight SQL, then you can sometimes get straight to the data without having to go through that extra layer of obfuscation, right? Just my thought. Yeah, exactly. Beverin says sometimes things happen in the ORM that mystifies what actually gets into the database, right? That's the ORM is an extra layer between you and what's actually happening. And so there may be times when you don't want that layer. And so if you can actually write the SQL and talk to the database, then you know exactly what's going to happen for better or for worse. But still, right tools for the right job. Sometimes an ORM is the best tool. Yeah, exactly. That's a great analogy there, Rascal. For talking about using the Git command line interface versus using the GUI. Um, yeah, sometimes you can't do what you need to do using the GUI. Sometimes you do need the command line, or the command line is just much faster. Um, And Beveran says, I worked at a place where that happened, where what happened in the ORM caused all sorts of problems with the data. And it was like, why is it like that? Yeah. And so sometimes you don't know, and there's no way to find out, because it's a black box. And so black boxes are not what you want when working with large sets of data. Um, but like I say, I'm hesitant to call anything bad. Sometimes it's not the right tool. Sometimes it is. Yeah, it's not that necessarily Hanso High. It's not necessarily that ORMs are beginner friendly. It's more of the analogy of if you are using an ORM, you are limited by what that ORM can do and what it can't do. And it may not it may not be able to do everything that you want to do with your data. And so if you know some SQL on top of that, you might be able to bypass the ORM and do what you actually need to do, right? Yeah, and sometimes you can't avoid an ORM. Sometimes that's your only option. I have just always written SQL, so I'm really comfortable with it. But not everybody can be. That's just not everybody's role. So, yeah. Okay, so let's do our animation here. That's a great question though. I like it. All right, so when we're animating, it's all about time. So when we're animating, we always want to be keeping track of the time, how much time has passed between the current frame and when we need to show the next one. And so we're keeping track of the time. So it's going to be time elapsed, and we're just saying, all right, how much time between now and when we started? Um, and if we've reached a certain threshold with the amount of time elapsed, if that's greater than the time that we have already stated is the interval for our frame. So depending on what level we're on, that could be faster or slower. So the higher the level, the smaller that interval. So if time elapsed is greater than the time level for that level, time between frames, then we reset the timer. Time start now, and we essentially draw the next frame. Rascal says Mongoose is much friendlier than raw MongoDB, for example, but not all ORMs and libraries are the same. Yeah, absolutely. Yep. Some are really terrible, some are great. Um, oh, and what this is doing here is essentially saying if you if a drop so if the piece is trying to tick down and draw the next frame and tick down, but it can't, which means that we're there's no pieces are able to move on the board, then we trigger the game over condition. So this probably means that we're at the top of the board, the piece can't move, and we call our game over condition. However, if that's not the case, then we can simply go ahead and draw the next frame. So we clear the canvas first. And each time we do this, each time we draw a new frame, we're not just moving the single piece, we're redrawing the entire canvas. So it's like we talked about before, with animation, you're not changing a single element. You're taking down the sheet of paper that's currently up in front of the camera, and you're putting a new one up there. So that's what we're doing here. We're clearing it out. CTX canvas height, and we're redrawing that canvas. Board.draw, and request ID is going to be equal to the next frame. Okay. Bevran says, from what I've seen, ORMs are for developers who don't know SQL, so it allows for code first development. Yeah, sure. Yep. Like Chris was saying, it's the right tool for the job. And that's, I do know SQL, so I don't use an ORM, but if you don't know SQL, you can use one. Yeah. But I would still suggest learning just basic SQL queries and syntax on the side, so at least you can troubleshoot, right? So if something goes wrong with the ORM, you might be able to access the raw SQL, just to look at it and see what it's trying to do. At the very least, you'd be able to read it and say like, oh, no, that's not what I meant. And, modify it maybe. Ellen Media says, I like SQL. Good to hear, Ellen. I am I'm a senior SQL developer in my day job. And then I just do, JavaScript for fun at night. JavaScript is so much more creative than SQL, though, I will say. I do love SQL, but it is a very single focus language. It talks to databases. That's all it does. All right. So that's our animation. Now let's go ahead and set up our game over functions that we're calling here. Function game over. And all we're doing there is really just killing everything. We want to cancel the animation frame that we just requested. Say, nope, never mind, we're done. And then we're just going to pop up a little message box. Oops, that needs to be brackets, not parentheses. And then we're gonna use the draw capability of Canvas to so we saw a little bit earlier how we can draw the shapes with Canvas, but we can also draw other things. So we're going to draw a little message bar that goes across that says game over. So we're going to make it black because that's depressing. And then we're just going to draw a rectangle. Fill rect. That's all we need to do. And we can set the coordinates for that rectangle. 3, 8. I'm not sure entirely what these mean, but this will draw a rectangle that's the proper size. We can set the font. And we're just going to say 1px Arial. We'll set the fill style. So it's kind of like we're doing CSS here. Oops. It's kind of like we're doing CSS here, but we're using Canvas to do it. So this is all just within Canvas itself. Fill text. And the text inside there is going to be game over. And this isn't anywhere like inside of our HTML or anything like that. We're literally drawing this like a picture on top of, everything else. Because the way that Canvas works too is you need to think about render order. So, we draw our board first and all these things are happening on the board. And then as soon as we hit game over, the way Canvas works is it just draws things on top. It draws like layers on top of each other. So our game over banner is automatically going to be on top of everything else because it's the last thing that we draw. So we won't have to worry about its positioning or anything like that. It'll just work. Ellen says, I like SQL, specifically SQLite and MariaDB. Okay, cool. Hanso says, crying in Oracle DB. So I am currently a PL SQL developer. So yes, I work with a massive Oracle environment at my day job, and it's a little spicy sometimes. Yep. I previously worked with Microsoft SQL Server at a previous role, T-SQL, and I found that Microsoft SQL Server is much friendlier than Oracle. That's just kind of what I've encountered. I was able to really heavily customize SQL Server to like do a lot of I used Redgate to autofill everything, and there's a lot of flexibility there that just doesn't seem to be present in Oracle. Yeah, but Oracle does have more types of joins. That's correct. It has extra stuff. Yeah, and MS SQL is not bad. No, it's not. Neither of them are bad, and they both just have their quirks. They're both a little different. All right, let's add our pause function. And this one's going to be very short because, as I mentioned earlier, pause, all that goes into pause is just stopping the current request for a new frame of animation. So we're already storing that frame, so we're not going to lose it. But we essentially just pause. And this is going to be triggered by a true or false value. So if request ID is true, animate, else pause. Oh, sorry. And then the rest of this function. And this is actually going to trigger the pause. So if request ID is false, animate, else return, or sorry, animate and return, exit the pause function. However, if we are truly paused, then we cancel the frame and set the request ID to null and display a pause banner. So we can copy this from up here in our game over. It'll look pretty similar. You can make it look different if you wanted, but we're going to fill it with yellow instead of red, less threatening. And our text here is just going to say paused. And get that nice and centered. Okay. Let me see if I've missed anything here. Rascal says, speaking of paws, when are we going to see some kitty paws? Yeah, I actually do have the same kittens that I had before. So the kittens that Twitch chat actually named. So for those of you who are new here, I have channel points rewards for naming foster kittens because I foster kittens for the Humane Society. So I go through, they rotate them through. Um, yeah, Twitch chat named my last three, which are Spot the Data Scraper. That's one of them. Catherine Janeway, which is another one, and leche, which is the third, meaning milk in Spanish. So yeah, I still have those guys. They are currently awaiting their surgery to get spayed. So I'm just holding on to them because the surgeries are all backed up, and so I don't want them to just hang out at the shelter. It's a stressful environment, and they actually had to go back to the shelter for a couple days over Thanksgiving, and one of them got a respiratory infection just after like a couple days. So it's best if they just hang out with me and have fun and keep me up at night running around my bedroom. So, but I don't mind it at all. Yeah. Okay, so looks good. We've got all of that there. One thing I am going to do is I'm going to take the moves where I declared all the different moves. I'm going to take those and just move them up. They should be up higher. Make sure I didn't accidentally get rid of a bracket there. So I'm just going to take moves and move them up just underneath where I'm doing all these declarations. Right there. Okay. We've got our board. Initializing next. I'm also going to move my event listener. I'm just moving a bunch of things prior to the play function, just to make sure that we're listening for keystrokes and everything. I think it'll be fine the way it is, but just kind of changing the order of some things. I'll grab reset game as well. I'm going to take these and move them up above play, and I'll push this in a minute since I'm doing some rearranging here. Okay, so after init next, we're adding event listener, got the scores, boop, boop. And reset game. And then the play function. Got our animation last. Board. Got our game over. And got our pause. Oh, I need to get rid of this event listener function, so I'm not declaring it twice. There we go. Okay. All right. We might be done. We'll see. All right. Gonna go ahead and do a push. Finished. Main.js. Should put a question mark on that. All right. Push that. Peachy. Okay. See, we finished piece. We finished board. All right, I've essentially done all of this without testing it. You know how I roll. If you're a frequent viewer, you'll know that I do that a lot. So let's just see if it works. Which is weird because like at work for my day job, I'm pretty meticulous about testing like incrementally. I just don't do it on stream for some reason. I just start, you're just rolling. All right. Uh-oh. That's not right. Let's see if we got any errors. I bet we do. Oh, no errors. Okay. Oh, so my grid is... Okay, my grid is there. Oh, now we've got an error. Okay, good. Get element by ID is not defined. Ain't nobody got time for incremental testing. Darn right. All right, get element by ID is not defined. Okay. That'll be... It's all in main.js. Okay. Let's see, where is that at? That's in update account. Oh, not in born, in main. Duh. Testing? That's extra. Yeah. Interesting. Why doesn't it like that? So the problem is somewhere in gestures to JavaScript. Yeah. We'll find it. Oh, documents dot get element by ID. Did I forget that every single time? Probably. Yeah. Okay. Let me just sure, I can JavaScript. All right. Okay, so that looks good there. Okay, so those look fine. Let's try again. Okay, so still not rendering properly, but we fixed one thing. Type ID is not defined. Okay. Oh, yep, I know what I did there. So in piece.js, I need to fix my spawn function because type ID, so this is a great example of why using the this keyword is necessary. Um, because without the this keyword here, since we didn't, like type ID is a property of the parent class of piece. So the parent knows what type ID is, but this child, the spawn, has no way to access type ID from inside of it because the scope is going in the wrong direction. So if you think about scope, scope goes downward from parent to like parents can access things that their children have, but the children can't reach up the chain. And so it needs to be this dot type ID and this dot type ID. And I imagine I did that at these other places too. So this dot type ID. So that's a great reminder of why this keyword matters. Let's fix that and then we'll try again. Okay. Oh, look, we spawned a piece. So it's still not quite there, but we're getting there. We're getting there. Reference errors be like that. So many this is yeah. Accounts is not defined. Okay, probably another missing this keyword at reset game. Okay, check out the reset game function. And on click. Oh, that's play. Okay, so that's why it's erroring out because of the play function. At okay, so reset game. So okay, reset game is the source of the problem. Okay, fair enough. And I bet that's a count.level, isn't it? Yeah, that's why. I have a typo. I made something plural that wasn't supposed to be. But yeah, I'm glad we're getting a little practice at troubleshooting here because troubleshooting, you know, is a valuable skill to have. I'll make this a little bigger so you can actually see it. So you too can witness the errors as we troubleshoot this. I'm not surprised. All errors are typos. It just depends on how many characters are off. Yeah. Okay, so we're still able to render. Good. Okay, now is not defined at animate, but it's for spawn. Oh, I forgot the this keyword. So when setting the color and the shape, I forgot that it should be this dot type ID inside of the square brackets. this dot type ID instead of just type ID. Yeah. All right, so inside of animate, it doesn't like now minus time dot start. Okay. What do we got there? And that's in main.js. Boop, 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 boop. Now, so in this one, the reason this is not working is because I never defined now. So it doesn't know what now is. We need to pass in now as a set value. So that needs to be passed in as a parameter with a default value of 0. So we pass in now. Now it knows what now is. Okay, we're getting there. Ooh, look, it moves. It works. It moves. Okay, so it's still not quite there, but if I reset it, the shape falls now. It's alive. It animates. Yes. The grid is it's still cutting off the grid, but okay, so no more errors. Uh-oh. I just need to figure out why it's doing that. Because if I hover over this, if I hover, oh, nope, there's an error. Okay, good. Oh, I misspelled something. Okay. On clear lines. So that what that means is that a piece made it to the bottom and it is checking to see if it can clear a line, and then because I have a misspelling, it is not able to clear it. So for every value, okay, row.every onto the silent errors, yeah. Okay. See if we get any more errors once the piece hits the bottom. I'm also curious to see if it spawns the next piece. Maybe it's just, oh, there we go. Oh, I think all the pieces are like miniaturized. I think it's my board is the wrong size. I think let's see if I can go back up to my main.js where I'm actually setting the board size. Oh, it's making my board the size of my, it's making the board the size of where the next piece should display. Okay, so I think I have something switched around there. So yeah, because if we look at it, there's no next piece being displayed, and this is the correct size for where the next piece should be. And all my pieces are getting like squished into a weird aspect ratio because of it. So I think it seems to be working. I just need to figure out where I put the wrong canvas size. So init next, these are all CTX next values. Good. Let me look in board.js here. Just need to find wherever that is, and then that should fix it. There's my game over message. So that works. Let's see. This is where I'm setting my canvas size. So that's fine. Get new piece, draw board. Let's look at draw board. Oh, okay, so that's fine. It's drawing the grid right. It's just not drawing the outside of it. All right, I'm going to push what I have, and if anybody spots it, you win a cookie. All right. I'm going to keep looking, though. I'm just going to push what I have. the fixed version. Git commits cp-m and say fixed errors, some errors. All right, there's a fresh push for you. See clear lines, valid, freeze, draw board. I'm gonna make sure the draw board is correct for each. Grid. Oh, wait, no, that's right. Never mind. Like throws, Ray calls, fill. Piece draw. Initialize. Init next. Let's check something here. I'm gonna be mumbling for myself, like to myself, in kind of a distracted way here for the next few minutes. So feel free to do a, put on some music or a movie, and drown me out if you prefer. CTX next. Double checking that I'm drawing everything okay there. Let's see, where am I calling init next? Only those two places. Init next is hooked to CTX next. Let me try to declare that properly. Okay, so canvas, get element by ID board. Okay, making sure that I'm hooking to the right HTML elements here. That would be the most obvious mistake. And then canvas next is hooked to next. It should be the next piece here. Okay, let me just see what that looks like. Okay, so my ID is board. And oops, on the right side, Rascal spotted something. Okay, I'm just going to check this real quick, and then I will look at that. Canvas ID is next. Okay, so I'm linking to the right thing. I'm making sure what I'm doing is I'm making sure that I'm trying to set the sizes to the correct HTML elements. Looks like I am, so that's good. Look at init next. Okay. So for init next, this is where what we're doing here is we're actually setting the space for the next piece. So it should be not use the row and calls. It should be small. It should be a 4x4 grid. The actual board, yes, should be rows and calls, but this init next is specifically initializing the grid for the specifically initializing the grid for the uh, next piece thing here. But I think I have my wires crossed somewhere between init next and init, because that's right here. That's over in the board. Um, this dot init ctx. Looks like Rascal just went ahead and put the rows and columns in there as well. So yeah, I mean, I know I have I've got that tells me that I have my wires crossed somewhere between init and init next. So let's look at this here. So it only calls it there and there. And in main, it's only called there and there. So I still don't know where the problem is. I mean, I could change that. Yeah, I could just do, just essentially duplicate it for a quick fix. Yeah. So essentially what this is doing is it's making, so we can double check that everything else works, which it appears to be. I still want to figure out where I cross my wires though. So init next is setting this. It's setting the space for the next piece. So if you see here on my screen, there is no next piece is being displayed, and it should be. So we should see the next piece on deck here, but it's not showing up. So I think if I inspect this, we should see that there is a very large. So the grid isn't even actually visible now anymore because there's no init next. Yeah, it's so there. Like I said, that's I have my wires crossed somewhere where I'm referencing the wrong canvas. So with this, the game does work. I'd still like to find my mistake though. Oh, line 4. Okay, let me back out these changes then. All right, save that back the way it was. Line 4. Let's see, line 4 in main.js. Checking my notes here. Oh, you're right. Yep, it's referencing the wrong canvas. I even looked at that and I didn't see it. Y'all saw me. I was looking at the IDs, but yep, that's it. There we go. Hey, check it. So the whole time it was passing the wrong context in. Okay, so that's a problem. It's not clearing. It's not clearing properly, but that's a minor problem. Easily fixed, I'm sure. Oh, but we've got. Was that something that was able to go off the screen there? Pretty close though. Yeah, so that seems to be right. It is not. It's still not clearing this, but that's pretty close. So it looks like we're missing a get context on canvas next. No, I think what your first thought was right there, Rascal. Get element by ID next, CTX canvas, canvas, CTX next is canvas next. Yeah. Tetris is playable now. Hey Elias, we have we've got the perfect Discord for you. So in chat, do exclamation point Leon. Howdy, by the way. Exclamation point Leon, Leon. And you'll see there a link, a Discord link, the third one down. leonnoels.com/Discord. It's a hugely active community. And yeah, tons of people hanging out there and doing all sorts of code help. Whatever code you want to practice or work on with others, that's the place for you to do it. So good things that I see here is that game over works. The pieces are stacking appropriately. They're freezing when they should. We're just not clearing this this next piece, and the score is also counting up as well. So score is working, stacking is working. We just need to clear this mess over here on the right. So so Elias, also I'm curious, we'd be implementing T-spins, let alone focus. Yeah, I'm not going to do anything else with this really. Uh, I'm just right now. I'm just trying to figure out why this is happening. But yeah, we're almost done. We're just fixing errors now. Um, pause. Over. Let's see. Okay, maybe something in the animate here. Clear, because it should be clearing the frame at each point. It shouldn't be stacking. But what we see here is actually the standard behavior of Canvas, in that when it draws something, unless you tell it to clear, it always clears on top of it. Always writes on top of the previous frame unless you clear the old one. So that's what we see here. I imagine I'm probably missing an call to animate somewhere. Um, nope, maybe not. I will find it. I always do. All right. I'm looking at my notes over here on the other screen. That's working. Key value setting is working. Reset works as well. I want to see if the clear line function works. So if I can clear lines. Playing without the next piece thing working properly is like playing on extra hard mode. It's like, guess which piece it's going to be. No way to tell. Yay. Okay, so lines are clearing. That's good. And the line counter is working. So that's good. Nice. And I assume once I clear 10 lines, I'll move up a level as well. Oh, in board.js, I misspelled width as width. So, Elias, are you really good? Like, are you really good at Tetris? I'm just curious because I'm always curious about like the professional strategies in Tetris. Um, like, there's so many terms and jargon and stuff. Are you like a professional Tetris player, Elias? Okay, board.js line 33. You play competitive Tetris? Dude, that's so cool. Oh man, everybody ask Elias your Tetris questions because they play competitive Tetris. That's so neat. Let's see. Ah, ha, yes. There it is. All right. Let me make sure I get this right. Good catch, Rascal. Thank you. I got distracted playing Tetris. All right. Get new piece. Canvas. This.ctx next. I'm going to format this a little better so I can read it. So this not ctx next. Canvas.width. Width. Canvas.height. Okay. Oh, there we go. Yeah. Now we're cooking. Look at that. Rascal coming in clutch as always with the save. Um, Being able to stack without hold is called piece indifference. Okay, I'm curious to hear from the expert here. Yeah. Um, you rank on Tetra IO. X is the highest. You super grandmaster in chess. Holy crap! Holy crap! That's amazing. That's so cool, dude. Wowzer. So I think what Elias is saying is they're like second. They're like the second highest rank, which is amazing. That's really cool. Why am I getting all? That's so weird. Getting might not be as random as it seems. I feel like I'm not getting very many of the. No, I think I'm getting all the piece types. I'm basically what I'm doing is I'm making sure that um, my array logic was correct, and it's truly giving me all the piece types. I think it is. Let's see, we got one, two, three, four, five. Let's see, one, two, three, four, five, six, seven. Yeah, there's seven piece types, so it's giving me all seven. Good stuff. Okay. Well, that's really cool, Elias. What do you practice on? Do you have like a special Tetris like controller, like do you have the like the buttons, like an arcade style setup, or do you play on a keyboard or with a control? Like, what is your method of playing? Because I know that like that matters a lot to those guys that are really good at it, and guys and gals. That's old school Tetris. Okay, I don't know about the different types really. Modern Tetris. Okay, so what's if you don't mind indulging, what's the difference between old school and modern Tetris? Is it like arcade Tetris versus um, PC Tetris, or what? I use just a mechanical keyboard with silver switches. So anything with the name Tetris in full has very specific constraints. Okay, keyboard nerds. Uh, Elias, if you want to get good at Tetris, use silver switches on your keyboard. That's really cool. I appreciate you sharing that, Elias. It's rad. Tetris expert. Ah, okay. So you play. So Elias plays on Tetra IO, which doesn't have Tetris in the name, so it can have custom rule sets. Okay, yeah, that's really interesting because of legal reasons. Yeah, I know that the Tetris. I've heard that the Tetris trademark is like super specific. Yeah, I've actually heard that. And here we are building a clone. Maybe I shouldn't have named it Tetris. I'm not trying to sell this, for the record. This is for fair use, community use only, not for sale. Now I'm gonna get distracted playing Tetris. Let's see. Are we going off the screen? I'm just checking to see if my pieces are, if my collision detection is working. Looks like it is. I can't go off the screen, so that's good. Oh, I've seen, yeah, I've seen some of that high level play. I've really only ever seen the arcade play, but yeah, it's really cool. Only got 1,600. Yeah, I got. I think in the screenshot I posted on Twitch, or sorry, on Twitter earlier. I think I got up to 11,000, which I know is peanuts in the professional scene, but I felt like I did pretty well. And I'm only half concentrating right now, but um, it is fun. It's very absorbing. Yeah, things get glitchy if you can. Yeah, I noticed that if you rotate near a wall, um, like if you catch it at the right moment, it kind of glitches out. But I think it's still pretty good. And if I find any other errors in this code, so let me just pause for a minute. Pause. See, it stops the animation. So the pause function works as well. Let me go ahead and push this now that we've fixed all the errors, or all the errors so far that we know about. Um, okay, I'm pushing this up to GitHub now. Um, and so that's the most error-free version that we have so far. But yeah, I think it turned out pretty good. There is there is the potential to add additional features to this to make it look more like the real deal. Um, we could add like music. You could add sounds when you score or when you clear a line. I think sounds would probably be the next thing to add. But that's up to you if you want to add that. Yeah, sounds, and maybe some like local storage. What about local storage for scores? So you could store your score um, locally in like high score, I guess, and you could have a high score table that you could reference like on your machine, or you could store it in a database um, if you preferred. Yeah, high score local storage or database storage for like if you want to make this competitive, with a group of friends. Um, Store your score in a database and everybody can access a global table. Um, yeah, you could do that, or have it be arcade style where you have to like enter your initials and then and when you get a high score, that'd be rad. Time to put this in the portfolio and get a job in game dev. Man, I don't want to. I really like value the work that game devs do. I don't think I would want to be one, honestly. It seems like a very, very challenging role. Um, yeah, in a lot of ways. Tetris says get good at game over screen. We can do that. I like that. Last change. I probably wouldn't even push this. Is it get good? All right, I'll force a game over here. There you go. I'm not gonna say that. There we go. Yay. I changed it back, but you can. I don't want to accidentally push that to GitHub, but you can make it say whatever you want. 100 meme lords. Yeah. Okay, so I think this turned out pretty good, honestly. I'm gonna keep looking and make sure that there's not any additional errors that we just haven't found yet. But I do think it's working as expected after like the fifth or sixth try. But we got it. Um, Suddenly 100 forks for me. Yeah. No, honestly. Um, like I said, that's why I put my GitHub out there. Exclamation point GitHub. If you just joined us and you want to see my GitHub, it's not impressive, but I do have a lot of starter projects out there, like templates for things. And I do those on purpose because I want people to take them and build better things on top of them. So I want to give you the foundation to build something cool, whatever that might be. And just kind of give you a good jumping off point. And again, these videos, all these VODs are stored on Twitch for 60 days. But prior to that, I always move them to YouTube. So exclamation point YouTube. If you want to link to my YouTube channel, there's a ton of videos on there now, going back several months, um, going back all the way to almost the start of the year. Well, a few months in. And yeah, and on a variety of topics. So if you want to see any of those, feel free to check out my YouTube. It's ad free. I don't monetize my YouTube channel, even though I could, because I want there to be an ad free option for you as well. So if you want to avoid Twitch ads, go to YouTube, and I will move my current Twitch videos to YouTube here pretty soon. Only foolproof way to ensure this works is expected is to build a Tetris playing bot and point it at the game. There you go. Get on that, rascal. Okay. Well, any questions or things you want to ask about this project or about me or my day job or anything like that. I appreciate hearing from Elias about professional Tetris playing. That's pretty cool. So yeah, anything anybody wants to ask about, you are welcome to do so. Let's see. Yeah, I think I have pushed everything. Good. Yeah, I can I feel like I should rename this now given how fanatical Tetris is about copyright, but again, I'm not selling it, so well, for those of you who did hang on through the whole thing, I appreciate your tenacity. um, and how do you I have a question. How do you organize your approach to starting a big project? Oh, that's a great question. Yeah, so the first thing I kind of do is um, organize what exactly I'm trying to achieve. So have a really try to have a good goal in mind, but not a goal that is going to be too lofty or complicated. So starting out with sort of like a how do I get to the minimum viable product or the minimum level of functionality in my app that is going to demonstrate what it should do, but in a non-complicated way. So minimum viable product first, and then you can add additional features once you get the basic product working. So um, minimum viable product first, additional features later. And I tend to, then after that, I tend to think about like any paths that I might need. So if I'm building a full stack app, I think about, okay, what is the data that I'm going to be sending back and forth? What specific data elements am I going to be sending, from the user interface to the database and back? And how should those flow through the app? So thinking about the data elements that I'm sending back and forth and kind of drawing those connections. Um, and um, so thinking about the types of connections that I'm going to need to make, and then I usually start building out the back end functionality. So what do I need to set up in my database, um, and then start coding out the back end first usually, um, and then just the minimum interface that I need for the front end in order to test things. I and then styling last. I'm not very much of a designer or visual person. So some people do things in the opposite way. They'll start with the user interface. They'll get it looking real good, as sort of a proof of concept for their audience, um, and then and then they work from that to the back end. I mean, you could go either direction. Chris says, any plans for the next couple streams or just playing by ear? I do have some things I do want to, stream on at some point. I do want to, as Rascal mentioned, I do want to talk about TypeScript. Um, I think I think TypeScript is really interesting. I haven't really had the time to um, flesh something out for TypeScript, but I mean that's why I shared those docs on Twitter. Um, is because I think that TypeScript, as we start building more, as you all start building more like structured apps and apps that are actually user facing, I think TypeScript can provide some additional functionality that can help safeguard your inputs and make sure that your app is truly doing what you expect in all cases. So I think TypeScript would be good for that. I don't know if Leon plans to talk about it at some point when he does start streaming again. I wanted to check with him and see, um, to make sure that we don't cross our wires there. Um, but I would like to talk about it. Yeah, exactly. And so, for example, if we had been using TypeScript on this project, um, the yeah, TypeScript would have caught them. TypeScript has really excellent, um, and really strict error catching and error handling. Um, oh, thank you for the follow. Oh, and whoa, CM Griffin just rated us. Holy crap! Okay. Oh, hey, CM Griffin. Hey, Kexat. We're playing Tetris because we just built Tetris. So we just built Tetris, and now we're enjoying the fruits of our labor by playing it, um, here for a bit. and just kind of talking about the merits of TypeScript and how it could have helped us with some of the errors that we encountered while building Tetris. Yeah. Okay, Gavin's awful stream. I love your username, by the way. I'm sure your stream is not awful. Mediocre at best. Ah, come on. Yeah, so we just finished building Tetris here. Um, just using vanilla JavaScript and the Canvas API. Just showing what you can do with basic drawing and animation in Canvas. Nothing spectacular. I know that Canvas can do a lot more. But, just kind of exploring some of the basics of it and setting up some animations and game logic with, the no special tools. Ooh, I'm going to clear a line. Yay! So what were y'all working on? You still, CM Griffin, are you still working on your menu app that you were building? Your sorry, not your menu app. Your food decider app. I forget what it's called. Sorry. Are you still working on that? Thank you for the rate, by the way. Thank you very much for that. I appreciate it. The meal app, meal action. That's right. Yeah, the only meal action, right? Yeah. So CM Griffin is working on a cool app that helps like you and your friends um, decide on where to eat, like collaboratively. Um, Working on validating your open API YAML file. Cool. Yeah, definitely check out CM Griffin if you haven't already. They're a great friend of the stream. I raid them, they raid me. It's great, and they're a lot of fun to hang out with. So they're great, just sort of like chill, hang out stream while they work on their stuff and talk about cool topics. So worth a tune in if you have the time. It has uncovered bugs all over the place. Oh no. Oh, that happens, right? Yeah. Now you must play Tetris and entertain the. I know, that's why I started a new game, because I was like, we gotta raid. I gotta play Tetris. Playing Tetris while talking is certainly a challenge. So we actually just finished squashing the bugs um, in Tetris here. When we first tried to run it, that was unsuccessful, but we got it working. So now we're just sort of enjoying the fruits of our labor here. If you want, you can check out the repo. I've got my hands full, but if somebody wants to paste the link to it, you can do so. I'm too busy winning. Channel redemption when? For what? I missed it. Did I miss somebody redeeming channel points? I missed the context. Oh, to make me play a game of Tetris. Okay. Now, I don't know that you necessarily ever have to make me play Tetris. I'll just do it voluntarily. Like, I mean, I would just do a Tetris stream. I don't know. I see. Okay, so CM Griffin says, yeah, finding the errors is the point. Opening API is a contract, so validating that contract increases confidence in everything by a lot. It means that it uncovers many bugs from every part of the stack because it's basically an integration test. Yeah, yeah. When you add that extra, yeah, that extra layer of validation, any errors are going to bubble up. Mine's a competitive Tetris player now. Yeah. Notice the pieces coming out of the bag. Yeah, yeah. So we store the next piece in the console on the right there, and then that's the next piece that then appears in the on the board. Yep. You'll find less bugs lifting up a log in the woods. Hey, there's always going to be bugs. That's a fact of life. Everything has bugs. Bugs are actually very beneficial to the environment. You know, I like bugs. Not necessarily bugs, but so I actually learned recently that I actually have a like a genetic predisposition to be bit by mosquitoes. So like mosquitoes are like drawn to me like genetically. Um, which is something I'd always suspected because I would just be like outside swarmed with bugs and my parents would be like, "Ah, you're fine." And but yeah, apparently I have a genetic predisposition to being eaten alive by mosquitoes. So that's interesting. You heard it here. My bugs sustain the ecosystem. Darn right they do. That's right. Look on the bright side. It's your blood type? Yeah, I think it is. I think that's a part of it. Yep. Yeah, I have A positive blood, so apparently that makes me very bug friendly. Also target if you're diabetic. I'm not diabetic as far as I'm aware, but that's interesting because your blood is like sweeter, I guess. Ooh. Oh no, I lost focus for a moment. I lost. Ah, maybe I can recover it. No, I went off the screen. There's a glitch. My piece is stuck. I've got a piece stuck off the screen. It's all falling apart. I don't know if I can salvage this. No! Ah. Oh no. Oh no. Oh no. We're heading for disaster. Come on, line piece. I need a line piece. No, that'll do. Ah, got it. Yes. Ah, line piece. No. It was a good run. I got to, yeah. I was destroyed by my own creation. I mean, it's biblical, I swear. Yeah. My own creation has failed me. Elias says you can make it so instead of the pieces being random, they are taken randomly out of a bag. Oh, I see what you mean. So there's a starting bag of 12 pieces, and then like of actual like declared pieces, and then that bag is depleted, and then a new bag is. I see. So you're randomizing as a batch. Yeah, I mean that would be interesting too. Yeah. Is that how real Tetris works, Elias? I honestly don't know. CM says CM Griffin says the way you deal with potassium also impacts how mosquitoes like you as well. Oh, okay. What is it about potassium? Gavin says mosquitoes bite me then fly away on a sugar high. Like drinking corn syrup. Yeah, it's not a bug; it's a feature, right? Pieces stick in the wall for extra challenge. Yeah. Major Monkey says, "Wow, this new Tetris is hard." This is bootleg Tetris. We just finished building it, and I had to test drive my creation. Speaking of bugs, Windows Update is essential for planetary survival. Kicksat says, "I'm A plus, but I'm not particularly prone at being bitten by mosquitoes." Yeah, I mean, I don't. Yeah, it could be potassium, it could be genetics. I just did that like one of those DNA test things that tells you a lot of stuff about yourself. Um, and one of the things it told me was that I'm more susceptible to mosquitoes, which is just something that I've always kind of known, but never had proof of until now. My parents are always like, "Oh, you're fine. Put some bug spray on." And I'm like, "No, but I'm being eaten alive." Now I was able to be like, "See." Gavin says, "I'm the universal type, whatever that is." That's is it O negative? That's universal. It's like super good. Before you ask, no, you can't have it. Fair enough. Ah, Elias says, okay, so the way real Tetris works is that, yeah, there's seven randomized pieces in a bag. That bag is depleted, all the pieces are taken out, and then a new bag is randomized and starts over. Okay, that's interesting. Thank you for the follow, Only Pain Control, and Kexat, and JJ Lange, and Gavin. Thank you. Interesting. So you can never naturally have three pieces in a row, only with the whole. So you're talking about three of the same piece in a row? Yeah, and we could probably implement like some checks, like as a feature. We could probably implement checks on that to be like, um, if because what we're doing is we're essentially setting up a like a piece ID to match the shape with the color. Um, excuse me. And so we could say like if the current piece ID equals the previous piece ID, then draw again, get a different one. So we could do it so you never get two in a row that are the same. Yeah, three the same. Yeah, okay. Yeah, we could put some additional logic into that. And if I do, I'll push it up to GitHub so y'all have it. Um, Via Sanctus says, I always thought it had to do with carbon. I see we talked about mosquitoes. Uh, yeah, I don't know. I don't know specifically what it is that triggers it. Um, yeah, I mean, we already have like so talking about the piece randomization. We already have logic that you know. So we have an array of piece types, and we randomly generate an ID which goes into that array of piece types and selects. Um, Sorry, that was my dog. We have an array of piece types, and we randomly select from that. We generate the number, and then we randomly select from the array based on that number. So I mean, it would be easy to just um, say, hey, if new piece ID is equal to current piece ID, draw again, um, and yeah, that would be doable. I might add that and then push it up to GitHub so y'all can access it later. Well, I mean that's not a bad idea. No, I don't know. In my opinion, like there's no criteria or threshold of good dev versus bad dev. If you're writing code, then you're a dev, and all you can do is learn from others and get better as you go. So I don't think anybody should call themselves good dev versus bad dev. Good. Yeah, there's always more to learn, right? No matter how good you are, there's always going to be someone that's better than you. And so instead of like feeling discouraged, you can be like, yes, someone is better than me, so I can learn crap from them. Like maybe they'll teach me, or maybe I can look at what they're doing and learn how to do something better. So I love it when you're working with somebody that's like better than you. Like most of the folks that or more, I shouldn't say better, but like more skilled at what they're doing, right? Most of the folks that I work with in my day job are really skilled developers. Um, like way more experience than I have. And I love that because I'm like, oh, hey, so I'm trying to do this particular like thing, like, and I did it this way, but I feel like there should be a better way to do it. Do you know a better way? And they'll be like, oh yeah, you can just do like blah blah blah, this, and I'm like, yes, all right, awesome, I learned something. Um, yeah, so I love working with these folks like at work in my day job that are more experienced than I am. All of them are. So yeah, I dig that. It's fun. And then sometimes I make dingus mistakes, and and they're like, "Why did you do that?" And I'm like, "Oh well, I'm new, relatively newest. Although I'm not the newest person on the team anymore. We just hired some new folks, so I'm excited for them to learn too." All right, I think we're probably going to wrap up here in a minute, but I appreciate the raid, CM Griffin. Thank you so much, as always. We'll have to raid you back here when I have a chance. Um, and very excited to be back here on stream with you after with you all after missing a week, and looking forward to future topics. um, Also looking forward to see what Leon has in store for the future of 100 devs. Has he? Okay, has Leon done the Raid Shadow Legends stream yet that he was promising? Has he done that? Did I miss it? Because I'm gonna feel bad if I missed it. I didn't think I did, but I really that's something I'd have to witness. He's hesitant. Ah, I just don't want to miss it. I hope he does decide to do it, and I don't want to miss it. This week there might be a stream. Okay, I can dig it. Yeah, just hope it happens before Christmas, but we'll see. Yeah, I know there's all sorts of opinions about Raid Shadow Legends and how cliche it is, but I just want to see somebody play it without me having to. Also, he promised merch, and you promised merch, and I'm down for the merch. Raid Shadow Legends, yeah, not sponsored. All right, okay. Any last questions? Happy to answer. Questions, comments, anything like that. I hope y'all enjoyed building Tetris with me, um, and watching me play it because, like I said, I could just sit here and play it this whole time. I'm glad that Elias at least thinks I'm slightly decent at it. I really, I'm sure I'm no competitor, but it is fun to play around with. I basically have no strategy. So, thank you for the follow, L1086. All right, I'll just sit here playing the whole evening. I really should go to bed at some point. Actually, no, I haven't even eaten dinner. Like it's 8:30. I haven't eaten dinner. All right, I'm gonna have to go consume some food at some point. So, um, compare, yeah, no, I wouldn't expect you to compare me with anybody but beginners. So I appreciate that I am at least toward the upper end of the beginner stack. That's all I could ever wish for. You could eat sleep for dinner. Competitive Tetris training. There you go, Elias. You could start your own streaming and do Tetris coaching. There you go. Okay, well, I'm not hearing any additional questions. Of course, I'm happy to answer if anybody has any. But other than that, maybe we should start looking for a raid target to pass the love along that CM Griffin so kindly shared with us. Once again, if you want to see any of my past streams on a variety of different projects to help flesh out your GitHub portfolio, you can check out my YouTube channel, exclamation point YouTube, and my GitHub, exclamation point GitHub. I'll give you links to both of those. Um, and yeah, build something cool. If you do build something cool with one of my past projects, like if you take one of my projects and modify it, that's perfectly fine. Just please tag me on Twitter so I can see what you built, because I really love seeing when people build cool things based on my code. Because they always make it look way better than I ever could, because I am no designer. I do not understand visual composition or color or design in any capacity. I'm a back end developer by day. I mean, what do you expect? Um, but I do love when people, take my stuff and make it beautiful, and make it their own and add features and all that sort of thing. So just tag me on Twitter if you do make something cool so I can see it. I will see it. I look at every single thing that people tweet at me or tag me in. So yeah, much appreciated. All right, let's find. I'm gonna open a window here, and let's find someone to raid, shall we? All right, Aroni. Rady, rady, raid. Okay, who do we got? We've got, if as always, if anybody has any suggestions, I prefer that they're in the software and game dev category. Um, we've got, let's see, people who are actually doing game dev today. I see Team Vash and Time Enjoyed are online. Um, if there's no other suggestions, we'll probably pick one of those two. I don't know that we've rated Vash in a while. Um, excuse me. Last time I saw them, I think they were doing What they do? Unreal Engine. They were doing some game dev in Unreal Engine. I think. Let's see. I wonder what Time Enjoyed is doing. We did, but we just rated them a little bit ago. Yeah. Yeah. So how about let's go ahead and raid Team Bash. Um, and yeah. So we'll go ahead and raid them. Set up the raid now. Ba-ba-ba. Yeah, they're doing some kind of dev. And yeah, we'll go ahead and read them. And I will see you all again next Sunday. I'm kind of not from now, I'm not doing Wednesday streams, but I will probably get back to that at some point. I'm just kind of waiting for things with 100 devs to pick back up. But um, for now, I'm really just doing once a week, but hopefully to have a good topic for you next Sunday as well. And yeah, feel free to, feel free to reach out to me on Discord or Twitter or whatever. Always happy to talk. So I'll see you all again next Sunday. Check my Twitter for the topic. And yeah, hope to see you all again soon. Bye bye.